May I have your attention, please? The 9th REAAA Business Forum will begin shortly. So please take your seat and turn your mobile phone to silent mode for a smooth progress of the event. Simultaneous interpretation will be provided throughout the forum, so tune into channel 1 for Korean and 2 for English on your receiver. All participants and staff of the 9th REAAA Business Forum have been committed to complying with all government quarantine guidelines in order to prevent the spread of COVID-19 and help you enjoy a safer forum. So ladies and gentlemen, please keep your face mask on at all times. We appreciate your cooperation, and I'll be back soon.
Distinguished guests, ladies and gentlemen, I would like to extend my warm welcome to you all to the 9th REAAA Business Forum. I'm 원상정. 근데 계속 그냥 이렇게 가만히 있을
May I have your attention, please? The 9th REAAA AAA Business Forum will shortly begin. So please take your seat and turn your mobile phone to silent mode for a smooth progress of the event. And simultaneous interpretation will be provided through the conference. So tune into channel 1 for Korean and 2 for English on your receiver. All participants and staff of the 9th REAAA AAA Business Forum has been committed to complying with all government quarantine measures in order to prevent the spread of COVID-19 and help you enjoy a safer forum. So ladies and gentlemen, please keep your face mask on at all times. We appreciate your cooperation, and I'll be back soon. Distinguished guests, ladies and gentlemen, I would like to extend my warm welcome to you all to the 9th REAAA AAA Business Forum. I'm Won-Sun Jung, and it is my great honor to be here with you as MC today. And simultaneous interpretation is provided during the whole forum, so tune into channel 1 for Korean and 2 for English on your receiver. The 9th REAAA AAA Business Forum is committed to following the government's COVID-19 preventive measures to provide you with a more enjoyable and safer conference setting. So we cordially ask all guests here in this room, please keep your mask on at all times. During the conference, if you have any questions regarding the speech or presentations, please scan the QR code seen on the screen, or you can find the links on YouTube. And your questions will be shared during the panel discussion. Well, now, I'm really delighted to announce that this forum has been brought to be held in Korea, hosted by the Ministry of Land, Infrastructure and Transport, and co-organized by the ALI AAA Korean chapter and the Center for Smart Construction Technology, Korea Expressway Corporation, with the support from the Korea Agency for Infrastructure Technology Advancement. Today, under the theme of Smart Construction Technology in Road Engineering, 17 international speakers from the ALI AAA member countries have gathered on and offline to discuss and share valuable insights into the future of road engineering. The forum is being live streamed on the Korean Road Association International Road Center's YouTube channel. In so doing, we hope to share this meaningful time with online audiences not able to be here in person due to COVID-19. Without further ado, let me introduce today's special guests. When I introduce them one by one, please welcome them with a big hand. Mr. Dong-gun Park, Chair of ALI AAA Korean Chapter. Mr. Sung-hoon Lee, Director of Technology Policy Division, Ministry of Land, Infrastructure and Transport. Mr. Yoo-bo Kim, Executive Director, R&D Headquarters, Korea Expressway Corporation. Dr. Kyung-soo Yoo, former President of ALI AAA. Dr. Sungmin Michael Jo, Director General, Center for Smart Construction Technology, Korea Expressway Corporation. Mr. Myung-hyun Yoo, Vice President, Korea Road Association. We truly thank you all for your participation. Now let us have the opening remarks by Mr. Dong-gun Park, Chair of ALI AAA Korean Chapter. Please welcome him with a warm round of applause.
Good morning, ladies and gentlemen. Welcome you all to the 9th ALI AAA Business Forum. Personally, I would like to start the opening with my sincere appreciation to President Sung-hwan Kim of ALI AAA, Dr. Kyung-soo Yoo, the former President of ALI AAA, Mr. Sung-hoon Lee, the Director of the Ministry of Land, Infrastructure and Transport, Republic of Korea, and Mr. Yoo-bo Kim, the Executive Director of R&D Headquarters, Korea Expressway Corporation. And last but not least, Mr. Wardani, the ALI AAA Business Forum Coordinator, to provide generous support in today's forum. Under the theme of smart construction technology in road engineering, the total 70 road experts from ALI AAA members countries will have in-depth discussion on the current use and an exciting prospect of smart construction technology in the field. Changes in road engineering triggered by smart construction technology are already being witnessed everywhere. But I think full-fledged discussion are yet to happen in many countries. Successful anchoring depends on how fast or long it exciting customs and how actively incubate and nurture new ecosystem to be smart in many ways. Asia and Australasia that have a relatively stable ICT policy environment and many opportunities for mutual learning can do better. It is essential to have proactivity and creative approach through intensive mutual learning, and strongly believe that early AAA can play a pivotal role in such a phase. Early AAA is promoting various activities, including the business forum. The strength it positions as an international organization that actively support activities not only in the public sector, but also in private sector. I look forward to your continuous interest and support in this meaningful learning of the ASEAN and Australasian Law community that sustainable during the pandemic. And I promise the Korean chapter will be one of the trusted partner on the way. 감사합니다.
Thank you for your meaningful remarks, Mr. Park, and please give him another big round of applause. Thank you. Now we'll move on to the congratulatory remarks. First, we have Mr. Sung-Hoon Lee, Director of Technology Policy Division, Ministry of Land, Infrastructure, and Transport. Let us have him with a big hand.
Good morning. I'd like to send my warmest greeting to all of you here and those who are connected with us online. I am Sung-Hoon Lee, Director of the Technology Policy Division at the Ministry of Land, Infrastructure, and Transport of the Republic of Korea. It is my great pleasure to celebrate the opening of the 9th REAAA Business Forum with esteemed speakers and attendees from home and abroad. First of all, I'm grateful President Sung-Hwan Kim and Chair of the Korean chapter, Mr. Jong-gun Park, for making this significant meeting possible today. I always deeply appreciate the excellent arrangement of Korea Expressway Corporation for today's forum, led by Executive Director Yoo Bo Kim of R&D Headquarters and Dr. Sung Min Jo of the Center of Smart Construction Technology. As we have entered the era of new normal, spurred by the first industrial revolution and the COVID-19 pandemic, digital transformation is no longer a choice. It's rather become our top priority for survival. This is also true in the Korean construction sector, as building information modeling's an advanced three-dimensional process has increasingly becoming a norm. We are reaping benefits by saving costs and consuming less time for our construction projects. In addition, tasks that were mostly done at the construction sites in the past have been becoming more module-based or conducted at the factory through production and assembly lines. Likewise, the entire construction process is embracing brand new changes with the adoption of more sophisticated automation and AI technologies. In line with this, the Korean government set out a roadmap for smart construction technologies in 2018, and has since supported the industrial digital transportation in various ways. In 2020, we launched a national R&D project worth 200 billion won for technological development and established the Smart Construction Support Center to help startup business set up their ventures and grow. We also mandate the adoption of BIM, while allowing turnkey contracts to be tendered regardless of a project budget, once smart technology are applied. Overall, it would not be an exaggeration to say that the construction industry's future hinged on whether we will be able to develop and apply smart technologies we need, which will very much determine the safety and productivity of our work. I bet on a promising future. We are mostly like to see tangible achievements in the near future, since various attempts have been made early on to utilize smart construction technologies in road engineering. Ending my remarks, I sincerely hope that today's forums will make a great contribution to strengthen technological cooperation and exchanges among business of our 23 member countries for the fulfillment of our smart construction and digital formation in road. I wish you all of the productive meeting ahead and every success in your future endeavors. Thank you. 감사합니다.
Thank you so much, Mr. Lee, for your thoughtful messages. Now, we'll have another congratulatory remarks delivered by Mr. Yoo Bo Kim, Executive Director of R&D Headquarters, Korea Expressway Corporation. Please welcome him with a big round of applause.
Good morning. I'm very pleased to see all the experts attending the 9th REAAA Business Forum at home and abroad. I would like to express my appreciation to Mr. Sung-Hoon Lee, the Director of Technology Policy Division, Ministry of Land, Infrastructure and Transport, Dr. Sung-Hwan Kim, the President of REAAA, and Mr. Jong-gun Park, the Chair of REAAA Korean chapter. We are entering the digital era where traditional approaches are not competitive anymore. Even in the road engineering, the data-driven transformation has already begun, including the convergence with the ICT, BIM, Metaverse, and many more. Since our member countries are facing these changes in common, many meaningful topics for change are presented today. I hope that today's business forum will be a square one to predict and prepare for the future of road engineering that smart construction technology will bring. Korea Expressway Corporation will be always there with the REAAA to continuously support its activities. Once again, I would like to congratulate you on the successful 9th Business Forum and the inauguration of the President of REAAA and the Chair of REAAA Korean chapter. Thank you so much.
Mr. Kim, thank you for your wonderful messages. Last but not least, Ms. Lidwina Wardani, Ali AAA Business Forum Coordinator, will deliver the congratulatory remarks along with a brief rundown of the current status of Ali AAA Business Forum.
안녕하세요. Good morning. Honorary REAAA President, REAAA Korean Chapter, REAAA Council members, distinguished speakers, participants, and guests. Warm greeting from Jakarta. It is very honor for me to present these congratulatory remarks for the 9th REAAA Business Forum today. Since in this moment, the COVID-19 pandemic is still in transition to become endemic, this forum being held in hybrid event. Despite on this event, which we unable having physically gathered in the beautiful city of Seoul, I hope this event will not limit or reduce our spirit and dedication to bring this forum successfully done. Ladies and gentlemen, first of all, I would like to extend my gratitude to the major host of this event, Ministry of Land, Infrastructure and Transport of Korea. Also to the co-organizers and sponsors, our REAAA Korean chapter and the chairman, Mr. Jong Gun Park, Korea Expressway Corporation, and KAC Center for Smart Construction Technology, Korea Agency for Infrastructure Technology and Advancement, who has prepared and organized everything for this forum even today. As the coordinator of the REAAA Business Forum, please allow me to give a brief history of the REAAA Business Forum. Our REAAA Business Forum was designed for business-to-business or B2B cooperation to collaboration in infrastructure development, especially in roads and related sectors. We are delighted to announce that since the establishment of this forum in 2014, our REAAA has become the most dynamic road association in Asia and Australasia, with membership from individuals and institutions increasing every year. The forum are always held in conjunction with the REAAA Council meeting and or conferences. From its early years, the REAAA Business Forum showed its potential and demonstrated in high strategic value for REAAA. From the start, 8 forums had been carried out, and today's forum will be the 9th. The first 2 REAAA Business Forum held in Bali, Indonesia in April 2014 and in Sydney, Australia in October 2014. The third was held in Tokyo, Japan in November 2016. The fourth in Bali, Indonesia in March 2017. The fifth in Manila, the Philippines in July 2017. The sixth in Kuala Lumpur, Malaysia in October 2019. The 7th in Taipei, Taiwan in April 2019, and the 8th in Manila, the Philippines in September 2021. All the forums proved to be a great success. In this regard, our REAAA Business Forum can play an important role as facilitator to establish any business opportunities to be implemented among country members. Ladies and gentlemen, today the 9th REAAA Business Forum features prominent speakers from various countries will give presentations followed by panel discussion and question and answer session with the main topic smart construction, technology, and road engineering. I really hope that in the future this forum can cover wider range of issues or topics that even can reach not only REAAA members, but beyond REAAA. This can become opportunity as well, where this forum can be used as a platform in promoting REAAA. Also can provide us with more opportunities in building linkages and partnerships among country members. Our EAAA Business Forum welcomed the opportunity for business. Hopefully, in the near time, member countries should directly coordinate related B2B cooperation. Please welcome and enjoy the forum today. Thank you. Kamsahamnida.
Thank you, Ms. Wardani, for your valuable thoughts. And once again, I appreciate all the meaningful remarks by all the speakers. Now, we'll move on to a keynote speech of Dr. Sungmin Michael Jo, Director General of Center for Smart Construction Technology, Korea Expressway Corporation. The theme of his speech is Technology Trend Shaping the Smart Construction and its Industrial Application in Korea. Please welcome him with a warm round of applause.
Good morning. I'm very pleased to give a keynote speech for the 9th REAAA Business Forum today. I am working for Korea Expressway Corporation, Authority for National Expressway System of Korea, and in charge of the National Research Program to develop smart construction technology. Today, I will talk about technology trends shaping the smart construction and its industrial application in Korea, focusing on road sector. Now, digital is leading industrial innovation, and more people are interested in digital transformation. And digital can influence the fate of a company. Paradoxically, the pandemic caused by COVID-19 has been a catalyst for digitalization of all sectors of society, including the industries. Construction is the world's largest industry. However, productivity, profitability are very low and far from digital. As a new normal, digitalization is rapidly changing the global construction market. The size of the smart construction market in the world in 2025 was estimated as up to $1,570 billion. The governments of major countries such as United Kingdom, United States, Singapore, and Korea are implementing strategic policies to promote digitalized constructions. In particular, Korean government commenced National Research Program for Smart Construction Technology according to Smart Construction Roadmap, which was established in 2018 by the government. Then what is the smart construction? It can be defined as a construction method or system of achieving automation of the constructing process, data-driven operation, and virtual construction by converging digital technologies to secure high productivity and safety from the construction stage to the operation and maintenance period. Simply, it can be said as a digital transformation of construction. Smart construction can enhance the productivity, safety, and digitalization, and reduce construction time. Driving forces to promote smart construction are the enormous increase of data, new technologies, distinct benefits from practical examples, government's drive, and desperate hope for carbon neutrality. As I said, Korean government started a very ambitious program to research smart construction technology in 2020. This program consists of total of 12 task projects in 4 areas. Korea Expressway Corporation, KEC, is leading this program with more than 120 organizations participating. Then, how will the smart construction change the construction work? First, a 2-dimensional paper drawing-based design is changed to a 3-dimensional BIM design. And instead of humans, drones and robots will create a very detailed 3-dimensional digital maps and will collect various information on construction site. And equipment for earthworks will be operated remotely and autonomously. Graders and rollers for earthworks will be operated remotely and autonomously through hydraulic system control. And most of field equipment can be connected through a pairing between them and work automatically along a navigated route in the field. And the sequential and separated construction phase is changed to a system in which design and construction are interconnected on the basis of the concept of DFMA, design for manufacture and analysis, sharing a digital model like as BIM. And off-site construction, which means prefabrication or modular construction, will be generally applied. Automated multi-crane system will install a bridge girder system. And many kinds of sensors based on IoT can monitor the integrity and the quality of the manufactured members or material during transport. And a robot system will connect rebar cage and give a help to place the concrete for the bridge pier, which is on very high position. And the various IoT system and the sensing technology and the communication technology will enhance the construction safety in the field site. IoT sensors and image analysis based on artificial intelligence will help increase the safety in the field. We can find risk factors in the field site, and robot system can make a digital map to define a field condition. And we can check whether the members or materials are damaged in the field site. Above all, it will be also possible to conduct a simulation or virtual construction thanks to the platform-based digital data operation. Now I will introduce some use cases of smart constructions in Korean territories. Since last year, Korea Expressway Corporation has mandated the three-dimensional BIM design instead of 2D paper drawing-based design. It means at the project for construction of Korean Expressway, two-dimensional drawing is not allowed. So it means quantities and 2D paper drawings can be extracted directly from BIM. And we are also doing real-time simulations and visualizations of driving condition, traffic condition, drainage, and environment at design stage. And we are also trying to utilize this digital model at construction phase. So we are trying to make 4D BIM to manage construction schedule and 5D BIM to manage construction cost for the project. This is the example for bridge construction. We are now constructing the world's longest concrete cable bridge, named as Godak Bridge, crossing Han River. In this project, mobile management of labor attendance and the mobile monitoring of hydrate heat of placed concrete are now carried out. And we are collecting various data from the field site with the drones and various functioned cameras. And the proximity warning around equipment is generally being used. This shows virtual simulation of foam traveler works for construction of superstructure bridge and virtual inspection using three-dimensional model. And you can see machine guidance for tower crane to secure the safety around the equipment. And instrumentation using IoT to monitor the hydration heat of placed concrete for the girder construction. And we are also constructing the first road tunnel under the Han River in Seoul and Korea's largest diameter TBM tunnel. BIM-based 4D simulations were carried out for this project, and above all, common data environment to share all data between workers in the field, and for collaborations was applied now, and integrated construction management using a platform consists of smart dashboard, digital twin simulation, and IoT system is being used now. They show internet web-based 4D simulation. And weekend tracking location of workers and equipment based on 3D model and IoT sensing technologies. Virtual simulation of a TBM, a tunnel boring machine, and collaboration with the common data environment. And off-site construction using prefabrication and the modular construction concept is generally being used also. They are used in precast segments for TBM tunneling, precast arch, culvert, and retaining wall. Also, it has been widely used to construct bridge. the Incheon Bridge, Korea's longest cable-stayed bridge, which was completed in 2009, and recently completed last week, Turkey's Çanakkale Bridge, the world's longest suspension bridge, were possible thanks to the accumulated prefabrication technology of Korean construction companies. Besides, so many kinds of digital technology has been used for expressway project in Korea, and the Korea Expressway Corporation encourages smart construction by discovering and rewarding best practices from the field side. And the Korean government also encourages rewarding excellent cases through National Challenge for Smart Construction competition every year. They are slab management by IoT sensors, cloud-based equipment control technology, robot and drone system to monitor the site conditions, the slab finishing robot, and platform-based management, and the airbag installed vest system to secure the security of workers in the field. As I wrap up this lecture, I like to share some thoughts to open a new horizon of a smart construction. First, who is the leader of digital transformation in the construction sector? It means which domain of technology is more responsible for this digitalization? Construction engineering or information technology? We have to think that second, BIM is just an essential tool. Data is the key. So we need standardization and integration of data. The third, digital transformation is an entirely new one. It means it does not only use digital technology while maintaining same work. And repeating similar and costly works is inevitable for the time being. Lastly, we have to find a new value for smart construction. It means evidence of improved productivity and safety must be demonstrated and have to be proved. Thank you.
Thank you, Dr. Zhou, for your great keynote speech. Now, it is time to start the session 1 under the title of Industry 4.0, What is Smart Construction and How We Prepare. The first speaker of session 1 is here with us online. Mr. Gildam Satria is a BIM Manager PT, Waskita Karya Tbk from Indonesia. And he will talk about how Industry 4.0 reshape road construction in Indonesia.
Ladies and gentlemen, seminar's participants, fellow speakers, and distinguished guests, thank you for having me today. Allow me to introduce myself. My name is Gildam Satria. I am BIM Manager of PT Waskita Karya, one of the largest state-owned construction companies. I want to express my gratitude for the opportunity to bring presentation about how Industry 4.0 reshapes road construction in Indonesia. Since 2014, Indonesia has been building many infrastructure throughout the country, ranging from power plants, dams, and roads. The infrastructure budget in Indonesia from 2015 to 2017 continues to increase. In 2016, it was worth $18.6 billion and increased to $28.8 billion. Since 2017, it was relatively flat enough, though in 2020 it had increased to $19.4 billion due to the COVID-19 pandemic. On the other hand, a research report conducted by McKinsey shows that construction labor productivity has not kept pace with overall economic productivity, and the other research shows that the construction industry is among the least digitized, perhaps quite related to least digitized and productivity. The construction industry might still have more possibility to explore. For that, it takes breakthrough and innovation. Construction companies are challenged to generate a competent and productivity workforce in limited times and fulfill its needed. Waskita, as one of the largest construction services company in Indonesia, has several line businesses, including investment, construction, and manufacturing, where investment and road construction is the largest. PT Waskita Toll Road, as one of the Waskita subsidiaries engaged in the investment and operation of the toll road, owns and operates hundreds of kilometers toll road in Sumatra and Java. With this large volume, minor improvement in running a business have a significant potential impact on the company's performance. Therefore, Waskita continues to find a better way to run its business. With so many projects spread throughout Indonesia from Sabang to Merauke, especially for infrastructure projects located in remote areas that have not been touched, a way is needed to carry out this process correctly. Thus arises things that become challenges to overcome this problem, such as productivity, production capacity, human resources, safety, supply chain management, financing, environmental problem, and others. With technology, it can help us to overcome some of the above issues. We need agile resources capabilities that are easily adaptable to technological changes and versatile. We need to be able to generate new resources and improve the competence in a short enough time to be able to answer the need of help to face so many projects as described earlier. In addition to being driven because of internal needs in implementation technology, the Indonesian government also made policies that further encourage companies in Indonesia to conduct digital transformation as follows. In the year 2018, the Minister of Public Works of the Republic Indonesia, number 22 years 2018. It requires the use of BIM in construction of state building with criteria of the area above 2,000 square meter and more than 2 floors. And number 11 SA-DB-2021, the implementation of building information modeling in technical planning, construction, and maintenance of road and bridges. Ministry of Trade of the Republic of Indonesia, to encourage the industry to transform into Industry 4.0, Ministry Industry feels that the need for an index which can be used to measure the level of industrial readiness in Indonesia. It's called Industrial 4.0 Readiness Index, abbreviated as INDI 4.0. The assessment criteria include digitization, smart machines, smart product, data-driven services, connectivity, storage and sharing, autonomous project, and others. The policy has moved companies in Indonesia to measure and carry out a change plan in adopting digital technology, including construction companies such as Waskita Karya, which massively started adopting digital technology by 2018. Good news, at this time, there are quite many technologies that we can use to improve performance, such as extensive 4G internet access, cloud storage and processing, laser tools, IoT devices, virtual reality, SAP, BIM, and GIS. In 2021, Waskita has also published ongoing project and new project at Geospatial Information System as data center and information distribution. We use the Geospatial Information System as a big data container process and access geospatial-based data for all projects. Project data in geometry or BIM and non-geometry data can be accessed by all stakeholders easily, quickly, and does not require special software. In addition, placing data in GIS platform will open innovation opportunities to improve the company performance and managing future construction projects. Some of the improvements are to monitor the heavy equipment use, combining with IoT sensors for fuel and equipment productivity, to monitor the performance of the tools we use, fuel consumption, and others in real time. We use artificial intelligence to calculate the number of trees that will be removed on the path that will be built infrastructure. We can also use artificial intelligence to perform quality control over road projects to find and report which areas are not suitable or defective. This method will also help toll roads management or operation. In addition, There are many more improvement opportunities in the future as the impact of running the process digitally. In the planning stage, the technology to support surveys such as drone, photogrammetry, laser scanners, and LiDARs give us the convenience to map existing conditions very quickly and accurately so that we can get the context about the needs of the project's location that we build. For example, in the project plan of Indonesia's new capital city, the city of Nusantara in Kalimantan, where currently the city is still in the form of forests, we can get a 3D model of contours quickly using a digital surveys. By having a digital 3D model, we can do an automatic analysis such as analysis for flood areas, determine the sites, assess alignment line from the location to another location, in planning the road by including several constraints as criteria and complementing with data on the land condition, residential area, material location, land price, and set goals such as the lowest carbon emission, the budget, so that the system can propose some of the best alternative for us to decide. Waskita Bottom Precast publishes a catalog for their precast product in 3D BIM format that can be downloaded, making it easier for anyone, prospective users, to choose product and use them when designing projects, especially road and bridges. They can choose 3D model from a wide variety of girders, then download them to place in their 3D design model to directly see and learn the design based on the product that is actually on the market. In addition to the 3D model, this data is also completed with technical specification and test results. This will make it easier for planners to complete their design, cost estimate, and procurement. In addition to utilizing components of the catalog data can be accessed on the website. Planners and contractors can also create their model with parametric modeling system and even generative model. Models are generated based on an input data such as location, coordinate, elevation, etc. The process of production information becomes swift and easy to use. The 3D model also provides the drive to perform performance analysis tests, the strength of the structure against loads, energy consumption for building project, and other studies. This fast and automated process allows a project to test the design in various scenarios to get the best solution. This digital data makes it possible to produce documents and bill of quantity instantly so that the design process and cost estimation are estimated simultaneously. We can see the impact of the design and cost and want to change the design to adjust the desired criteria. So that before a project is constructed, we can see what the project will look like, including control condition, existing final condition, performance and visualizations, and stage of implementation. Previously, we tried to understand the project based on image and mock-up. With this digital process, we see the project in 3D without having to do a 3D creation process based on 2D images, because 3D data is the source of the 2D documents and bills of material. 3D visualization on a monitor, virtual reality, or 3D physical model we have obtained since the beginning once the stage. There are also tools to convert digital model to physical object. We use these robotic machines for steel fabrication in PT Waskita Karya Infrastructure and toll road projects. At the stage of the construction, the information distribution process, the submission of the model, and image approval can be conducted online and electronically. These changes have made the process faster and more accountable. At the end of the project, the entire data will be organized, which is very useful in continuing to the operation and maintenance stage. Having digital data throughout the projects provides an easy way for PT Waskita to provide training using virtual simulations. Project data that is already a 3D model is used as training material to simulate field condition. They can get virtual experience before they get into the field. This method makes the training process faster and more effective, not just delivering training material, but providing the experience. In the future, the internet will be faster and more accessible. More technology will be emerged. This will make it easier to implement digital process and more advanced collaboration. By doing the broadest possible digital process due to productivity considerations of information security, accessibility, and others, we have also prepared ourselves to open up possibility to other opportunities in the future, such as the metaverse. Having a project database in the future to present a project in the metaverse ecosystem, we do not need to build from scratch, but simply by utilizing existing connector, then we can use among stakeholders for visualization, especially to those who are not familiar with technical document or image, so they can understand and experience the project they will build later. Also, we can integrate more easily with IoT sensors for the management or operation of facilities. So this metaverse has provided convenience for the application of digital twin and more affordable. Metaverse allow you to potentially improve sustainability in construction, such as virtual interaction enable interaction as in physical interaction, thereby saving energy and reducing emission for transportation and air conditioning in the meeting room. Digital twin with metaverse allow more interactive visualization of control, inspecting or regulating power in dangerous location or spaces with pollution, gas or emission, etc. can be done with robots and avatars. Monitoring personnel and where they are located or the location of problems, fires, disturbance, hazardous areas, and etc. can be presented virtually with realistic visualization. Preparing digital twin is more accessible and affordable because the platform has set up functions, so it takes less programming skills. Projects are more accessible for view and experience, especially to stakeholders unfamiliar with engineering drawings such as finance management, investors, buyers, and etc. Summary: appropriate regulation or procedures have not supported the digital process. For example, recognizing the work progress, submitting the design review process, and approving documents at a certain level still requires a manual way. We expect regulation to allow to those processes digitally. All stakeholders need to adopt, implement digitalization, and be part of digital environment to get the most out of the digital revolution. And then project scheme in Indonesia, such as KPBU, the Design, Build, Finance, Maintain, Operate, where entities is given the freedom to plan, build, finance, maintain, and operate, can be significantly improved by digital process because it's productive, fast, accurate, and integrated. This way, we can bring all the issues up front since we can exercise various of scenarios, simulate the project until operation, see the impact on cost, environment, and functionality before it's really built, and coming up with the best solution before executing construction. Very well, ladies and gentlemen. That's all my presentation about how Industrial 4.0 reshape road construction. I hope it gives you insight, especially in Indonesia. We should strive to utilize technology to improve our process, deliver better quality and sustainable projects. Thank you very much.
Thank you, Mr. Satria, for your great presentation. It was really impressive to see the relations between Industry 4.0 and road construction in Indonesia. Now, Ms. Yuhan Yan, Project Manager at Mo Associates, is joining us from Taiwan. Ms. Yan will deliver a speech about advanced technology for road design, construction, and management.
Good morning, ladies and gentlemen. I'd like to quickly introduce myself. I'm Yuhan Yan from Mo & Associate Incorporation. Today, I'd like to discuss advanced technology for road design, construction, and management. First, let me start by introducing our company. We're founded in 1975. MAA Group is a leading Asian architecture and engineering consulting service provider in the East and Southeast Asian region. We've got 46 years of experience, 1,200 professionals, and projects completed in more than 30 cities. We have 10 offices in Asia-wide region, including Beijing, Shanghai, Taipei, Bangkok, Singapore, and so on. We are a multinational group focusing on localized needs, and we provide integrated solutions from conceptual planning, general consultancy, engineering design, to project management. MAA Group provides engineering services in infrastructure, environment, land resources, buildings and facilities, and information technology. Our reference including Taipei 101, Taiwan National Stadium, Taichung Economic and Trade Park, Singapore Sentosa World Resort and Keelung Harbor Maritime Information Center. Here I want to introduce our digitalization history in MAA Group. From the 90s, we've started to develop digital applications. At the zeros, we focused on GIS applications, BIM adoption, and integrated project management system, which expedite the digital development. In the past 10 years, we implemented the new technology such as LiDAR, IoT, AR, and so on to enhance our management services. After introducing our company, I'd like to give a short introduction of our presentation today. We will introduce the advanced technology which we implement from designing toward the operation and management phase. We will also talk about how we develop the digital applications in road management, and REAAA is an important concept which connected the whole process. What is REAAA? It means a life cycle management services for road facilities with detailed 3D information modeling technology. This is also the main concept in our presentation today. My presentation is divided into 3 parts. First, BIM uses in urban development project. Second, smart road management. And finally, I'll talk about the applications of IoT. BIM uses in urban development project. In this part, I will share how we implement BIM over design to construction phase. Taoyuan Land Readjustment Project is the first project implemented BIM to large urban land readjustment in Taiwan. This project is a small city which encompasses recreational and residential functions, as well as provides job and travel opportunities. The completion of the area will encourage migration to the redeveloped district, reducing the gap between urban and rural areas. We mainly use BIM in 4 categories in this project: road, bridge, underground utilities, and underground facilities. In road, we use Civil 3D to transfer the 2D planning into 3D model and then export the solid road model based on the design information. For bridge, we will build up the structure component model, then use Revit to assemble the components to build different types of bridge. In underground facilities, we will build different type of facility model, combine it with the coordinate data, then import to the application we developed. This application will automatically place the facilities in the accurate position, elevation, and direction. In underground utilities, we design the pipelines through Civil 3D. Then we import the line planning into another application we developed. The application will build up the entire utility models in a short time, which makes the building process efficiency. After we build up all of the models, we will integrate these different categories like we showed on the slide, which contain facilities, utilities, road, and structures. The integrated model is allowed to do the clash detection, quantity estimate, and model adjustment by construction workability. Through this process, we could enhance our design quality and reduce our cost. After designing, we go into construction phase. We will readjust the model according with the road construction situation. The model will also combine with the construction schedule and becomes a 4D simulation modeling tool. The 4D construction simulation could not only support the progress review, also provide both the contractor and the owner a better visualization of the planned construction sequences. After the construction is completed, we will import design information automatically through our application. The information imported according to the request of Public Utility Database building. In the next part, I will explain what Public Utility Database is. And this is our second part, Smart Road Management. Since the 90s, in order to manage underground pipeline in New Taipei City effectively, we started to build up a smart road management system. This system combined new technology such as GIS, AR, big data, and cloud management with public utility database, which the data comes from the information we imported to the model, and we call this smart road management system iRoad. This is the iRoad system. It provides three main functions: road excavation management, pavement rehabilitation management, and common utility dock management. The mobile office will support three management systems in back-end, and the managed result will be shown on an open platform for the public to browse and inquire. At Road Excavation Management page, we could check out current road works, inspections, and excavation project information. This system could also use for applying excavation form and managing excavation project. New Taipei City had already using online application form instead of traditional paperwork. Pavement Rehabilitation Management provides real-time management of inspection vehicles, which equipped with cameras and GPS systems to instantly return inspection images and inspection records. The third function is Common Utility Dock Management System. This system implements 3D GIS and BIM technology to facilitate maintenance and management for sustainable operations. We will first build up a common dock BIM model, then combine it with 3D GIS underground utilities. The data will be imported to a comprehensive management system and show the managed result through online page. This online page provides visualized 3D integrated model which allows users to research their location by address or zoom in and out, rotate and create a section to check or inquire the facilities and utilities. After introduce the iRoad system, I would like to share how we implement IoT in iRoad. IoT, Internet of Things. In simple words, IoT means taking the things and connecting them to the Internet. When something is connected to the Internet, that means it can send information or receive information, or both. This ability to send and receive information makes things smarter. As we mentioned in our previous part, iRoad is a smart road management system. In order to manage common dock more detailed, the Common Utility Dock Management System integrated BIM with 3D GIS and import IoT to manage in more systematic way. This is a project we've done before showing how iRoad changed the way maintaining facilities. The problem with the traditional system is that it uses 2D drawings, usually lack of updated information and limited by controlling room, which makes utility management inefficient. With integrating BIM, GIS, and IoT, we can inspect the facilities in 3D visualized model on electric device no matter where we are. Implement IoT allow the management system access facility data. so the controllers can inquire real-time information and control the facilities in our road system, which address the management more effectively. Here's a facility information query example. When we click the air exhauster on the 3D model or the facility list beside, it shows the on-off operation. Voltage and current in three-phase systems also provide trend card information for the manager to refer. We also combined underground utilities with common utility duct model in AR technology. This AR technique allows utility agencies to inspect common utility position on road and inquire the information based on the public utility database. This function effectively improves agencies' mastery of information, also decreases pipelines damage during excavation. This AR app also combined IoT with QR code. By scanning the QR code on the facilities, we could quickly get the real-time operation information of it. As a conclusion, today's presentation shared how we implement various advanced technology for road design to management, started from decreased labor and management costs to build up a completely and effectively management system. In the future, we hope we could keep taking advantage of REAAA to support whole life cycle management services for our road. And this is my presentation today. Thank you for listening.
Thank you, Ms. Yan, for your speech about smart system implementation on road design, construction, and management. Next, we have Professor Spoutmalai Krisanachali from Kasetsat University, Thailand. The professor will give a presentation on towards Thailand's future smart highway construction and management.
Hello, thank you for joining me on this session. My name is Supawut Malai Krishnachali. I am from the Department of Civil Engineering, Kasetsat University. And today, we're going to be talking about some of the new technology that has been using in highway construction in Thailand. We're going to be talking a little bit about BIM, augmented reality, artificial intelligence, Internet of Things technology, and also how to use drone in highway construction survey. Building information modeling or BIM has been widely used in Thailand in the last few years, but mostly on building construction. Only recently that people start using BIM on infrastructure projects. Like in this situation, they use BIM for the U-turn bridge construction for the Department of Highways. And based on the experience, you will achieve a more accurate result for the cost estimation by using BIM. As you can see here, the green one is the result of cost estimation from the manual process, while the red one is the cost estimation from the BIM model. And the difference between the two are the human error that may happen during the manual process of cost estimation. Since BIM is a 3D model, it will improve the communication of the project. People will understand the construction drawing better. You will get less mistake during construction. You can also examine the problem that may happen beforehand, so you can plan accordingly. You can also integrate the construction project schedule with the BIM model. Like in this situation, they integrate the schedule in Microsoft project with BIM through Navisworks. So this way, you're gonna know what is gonna happen, and when and where, so you can plan the construction site layout better. You can plan your resource, you can plan your machine more efficiently. Also, the Department of Highway have been using BIM for the quantity survey of standard drawing. This is example of the application. So this way you can get reference bill of quantity or for all the standard drawings, and you get the amount of concrete, formwork, and also all the steel reinforcing that are required. And this way you can eliminate all the human error that may happen during the manual process of cost estimation. Also, you can significantly reduce the amount of time that you have to perform the cost estimation. People in Thailand have started using BIM together with augmented reality model. As you can see in this example, you can extend the 2D drawing with the AR model. So through your mobile application, you can see all the visualization of the plan view, elevation view, all the section view, and all the reinforcement detail. And this is another example of how to use augmented reality model with the BIM. You can put the BIM model on the real world location, like in this example here. You see, the building is not there yet. But if you look through your mobile application, you're gonna see the building is there. You're gonna see the real world, the model that's situated on the real world location, just like in this example here. You see the building situated on the real world location. You see people riding a bike there. So this is how we use the AR model with BIM. And this way you can plan your site, construction site layout better and more efficiently, because you're going to see all the environment in real situation. This is another example of the AR model. You see, the building is not there, but if you look through your mobile application, you're going to see the building is there. You see the real world location of the building. This is another example. You can look through this column and see all the steel reinforcing detail in there. Okay, it helps you with the rebar inspection and stuff like that. In terms of operation and maintenance, this technology also helps. Like in this example, if you look at this steel pipe, this is what you're gonna see through your mobile application. So you're gonna see all the pipe information, the size of the pipe, the thickness of the pipe, and all the specification of this pipe. So it helps you during operation and maintenance of the building. Likewise, if I look at this light here, I'm going to see all the specification of this light, the lifetime service of the light, the maintenance time, and all stuff like that. This is the benefit of integrating the BIM. Well, we have to admit it. The way we are using BIM right now, we just touching the surface of BIM. BIM can offer a lot more potentials. BIM can offer a lot more benefit. For example, I can envision in the near future, I can just go tell a computer, I want a house with 3 bedrooms and 2 bathrooms and 1 kitchen. Could computer just design and draw a BIM model for me automatically? So computer should be able to figure out where are the footing, what are the span between columns, and where are the windows should be, where are the doors should be, and then also perform structural analysis automatically, also perform cost estimation for me automatically. That's something that is possible in the near future, and a lot of research is being done in that direction. So in terms of highway design, of course, if you integrate BIM with drone and GIS, computer should be able to automatically perform geometric design and structural analysis design for the highway in the near future. If you integrate BIM with artificial intelligence, or you can integrate BIM with some optimization solution like genetic algorithm, the computer will make a smarter decision. So it can potentially reduce the cost. It can potentially reduce the time during your design and construction process. In some countries, people integrating BIM with machine guidance system, and let the machine guidance system automatically control the construction machine for you. So by doing so, you can get a faster work, you can get a shorter project duration because the machine guidance system doesn't have to stop for lunch. And by doing so, you can eliminate a human error and human intervention that may happen during the construction process. So you will get a better construction quality. You can also put BIM with blockchain. We all know that blockchain is technology around the corner. So we can put BIM on blockchain with smart contract and digital twin. I actually have a few of my students start working on this type of research to see if there are potential and benefit to integrate smart contract with BIM and digital twin. Regarding the AI technology, to be honest with you, it's still quite new for the construction industry in Thailand. We still not really put AI into real application just yet, but people have been doing a lot of research on AI technology in construction. Like in this example, we use AI to automatically detect whether this person is wearing a helmet, a safety vest, a hand protection, a foot protection. A lot of other research going on, like people using AI to automatically count the amount of workers that are working in the construction site. People use AI to detect whether the foreman is working in the construction site by detecting the color of the helmet. Also, some people have been researched how to use AI to automatically count the amount of rebar in construction. So a lot of research has been going on, but we're still quite a long way to put AI into real application. IoT is one of the latest technology that has been using a lot more in Thailand this day. Like in this example, we use IoT to develop some real-time monitoring and warning system for the landslide. So we actually install the IoT device at the construction site. Okay, and data is sent automatically through the NB-IoT network to the cloud server. And at the server, we have some analytical module that will perform the data analysis and issue the warning message automatically to the people involved. And these are some of the instruments that we actually install at the construction site. The researchers actually developed their own inclinometer to install in the construction site. Okay, this is the real station that we install. And we actually get the people in the area, the local people in the area, to get involved in the installation to help us to monitor and maintain the system. And this is the site layout that we put all the instrument in the real construction site. The researcher actually used some bioengineering technology like biochar, like erosion control blanket, and some live stick to help prevent the landslide at the area. Okay, this is just one of the example of how to use IoT technology in construction. But with the 5G network that is going on in Thailand, I'm sure more people will use IoT technology more and more in construction industry in the near future. The last technology that we're going to be talking about today is drone. The Department of Highway has been using drone a lot these days. They use drone for construction surveying. They use drone for construction inspection and monitoring. Okay, like in this example, the Office of Highway Traffic Weight Control has used drone for their construction surveying. They actually use a very highly accurate RTK drone. They start from establishing the ground control point, and then they do the flight planning. And these are the pictures that automatically obtained from drone. The picture has very high resolution. I think one picture is about 3 by 3 centimeters in the real world. They also get the elevation data from drone using aerial triangulation technique. These are the point cloud. Well, it's kind of hard to see, but we get the elevation point cloud from drone. And from the elevation point cloud, you can derive a digital elevation model or a DEM. So DEM is a representation of the 3D surface of the area. And then you can actually put the picture from drone on the top of them. And then you're gonna get like a 3D surface area automatically. From that digital elevation model, you can actually derive a contour line. And from this contour line, you can automatically calculate the cut field work of the construction very accurately. So drone is very useful for a very large area surveying, and the Department of Highway is really supportive of using drone because it can save a lot of work, it can save a lot of time, and you have like a visual evidence of the work from drone. So that's all the presentation I have today. I hope my presentation gives you some idea about the technology trend that has been going on in Thailand this day. And thank you very much for joining me today. Thank you.
Professor, thank you for your presentation. And it was really a good chance for us to take a look at the future of highway construction and management in Thailand. Now, Ms. Chao Chen Chang, Project Manager at TY Lin International Taiwan, will give a speech about application of smart planning and design technologies in Taiwan road engineering.
Hello everyone, this is Shaozhen Jiang from Taiwan, and it is my honor to be sharing with you the application of smart planning and design technologies in Taiwan road engineering. Here's my agenda. The presentation today will be divided into 3 sections. First, planning stage. I'll talk about the big data applications in traffic characteristic analysis. And then, design stage. First, I'll share with you the LiDAR and UAV survey data with Revit BIM model. And then, the roadway and land development design with Civil 3D software. Lastly is my conclusion. First, big data analysis. In Freeway Number 1 widening project, we use telecom data and freeway vehicle data to do the big data analysis. And further, we visualize it in Google Map form. We use telecom data to identify the traffic hotspot and congestion time on local roads. So we can show the video on the left-hand side. We can see the red spot here. It indicates that there's construction here happening. So since the video is being analysis throughout the day, so we have the time here on the top of the video. Further, with our freeway vehicle data, we can do the similar thing to find the construction on the freeway. So we see the video on the right-hand side. So we can see the construction happens near the city first. It's around 8 a.m. in the morning now. And then it became purple. It means it is more jamming now. So after 9 a.m. in the morning, we discovered that the construction going north to this area here. And the construction only ends around noon. So it is our target area. So after we identify the target area, the target construction location on the freeway, we zoom into that specific area. So we collect the vehicle data from 2014 to 2020, and we sort it into weekday, weekend, and holiday. The southbound lane is on the left side of the table here, and the northbound is at the right-hand side of the table here. So we noticed that the construction happens on weekend in the afternoon. However, The construction on weekend was improved from 2017 after the approval of using the hard shoulder. But then we found out that during holiday, there is still construction happening here. So we try to understand why, and we'll have a closer look at it. We discovered that on the northbound lanes from Tongluo to Toufen, the construction happens at two specific locations. First one is before Toufen entrance, here. And the second one is before the way station area. And there are both construction happening in the afternoon. And the speed dropped down to only 20 to 40 kilometers per hour. It is quite slow on freeway. First, let us look at the area before Toufen entrance. We discovered that the congestion starts near the end of using the hard shoulder. We then realized that the cause of the congestion here is because the traffic on the hard shoulder interwave with mainline traffic that is going to the Toufen axis. The interwave makes the traffic slow down and cause the congestion, as shown in the graph here. Then, let us look at the way station area. We found that the congestion starts at 122K and ends at 118K. Then we look at the horizontal around this area. We discovered that there are multiple reverse curves with small curves radius. And vertically, it is also quite undulated in that specific location. As a result, the traffic will definitely slow down in this location and cause the congestion over here. After we identify where the construction are and the cause of it, we give the corresponding improvement proposal. For Toufen, we propose to extend the northbound decelerate lane, and for the way station, we propose to extend the northbound accelerate lane. It can not only give more traffic capacity, but also solve the specific congestion problems. Then, secondly, I would like to share with you is what we did with LiDAR and UAV survey data, along with our Revit big model. We start by control survey, and then we move on to topo LiDAR survey, as shown in the picture here. Here is the survey situations. And then we do some coordinate corrections. And the most important thing is the point cloud modifications. Before the modifications, the point clouds are not overlapping with each other. After the modification shown here, you can see the two towers is overlapping correctly with each other. So here is our final LiDAR point cloud result. You can see clearly the existing bridge and the railway beneath it here. All the details here and even the electric wires of the railway here. This project is the retrofit of the existing bridge, so our design engineers finish the calculations and do the Revit BIM models in Revit. So you can see the capping here, the capping reinforcement here, and also the foundation enlargement here. The model is then combined with the point cloud data, as shown in the picture here. So you can see the point cloud here and also our Revit model. We use this combined model to check the foundation encroachment from the railway, as you can see from the top view here. And also we can review it in 3D. We do the construction analysis based on the model too. We put the construction machines there and do the horizontal clearance check. Also, we do vertical clearance check beneath the electric wires. The clearing is more than enough. Moreover, since we noticed that there are transmission wires on top of our construction path, so we use the point cloud model to check this vertical clearance as well. So the outcome is the clearance is 5.2 meters high. So our construction path is okay. third topic I would like to share with you is how we do our roadway and land development design with Civil 3D software. Here is the modeling structure in Civil 3D. First, we will have our survey data, and then we will generate the original DTM. If it is the land development project, we will have the urban planning layout, and we can set out our horizontal alignment based on the planning layout. With both this, then we can generate the alignment profile, and then we will generate the sub-assembly, and then we will generate the assembly according to our typical sections. With all this, we can generate our alignment 3D corridor. And moving on, we can have row intersection component and finish the row surface. For pipeline wise, after we have the alignment, horizontal alignment, the pipeline will develop its own horizontal alignment as well, and its own vertical profile as well. And combined with the roadway corridors and the pipeline networks, we can generate the combined models. So here is an example in our A21 project in Taoyuan City. When we have the original survey data, we establish the original DTM with this survey data. So as you can see, this is the generated DTM in Civil 3D. And then we establish the horizontal alignment as shown here. And then we do the vertical profiles. And when we do the typical sections, which is called assembly in Civil 3D, and combine these three, we can generate the corridor here in Civil 3D. Since it is a land development project, so we combine all the roadway corridors, all the row here, and we combine them together, and then we can have our finished surface DTM. For pipeline wise, we also established the pipeline models. Here you can see the common duct network and also the drainage and sewage network. And most important is that we also build up our pipeline manholes accordingly. So you can see all the manholes in common duct system and also in drainage and sewage system. For the pipeline vertical profiles, we can combine it along with our roadway alignment. So we can see in the profile view here, there are some manholes misput here in the yellow circle. So we can adjust it just on the profile view. So we drag it down to the correct location to do the adjustment. So here is our finished overall pipeline networks. So we combine the common ducts, the drainage and sewage system all together. And then we combine our roadway corridor and also the pipeline corridor into one big model. Furthermore, we can also do the conflict detection. So here's an example. The sewage manhole is conflict with drainage box cover. So we can thus adjust the sewage system here. Here is another example. So it is Xinzhuang project in New Taipei City. We also generate the original DTM using the topo survey data, and throughout the triangular method, we can show it in the elevation analysis wise. So in a darker place, it means lower parts, and the brighter one is the higher ground. So we also generate all our roadway corridors here. It is the combined corridors. So you can see we do the roadway intersection component, all of the corridor components here. Also for the pipeline wise, we also have our overall pipeline networks. So the blue one is the drainage system, and the brown one is the sewage system, and so on. And we also reference the 2D drawing here, so you can see the corresponding parts. We can also do the conflict detection here. So you can see the blue one is the drainage system, and the green one is the common duct, and it is the electricity common ducts. And the yellow one is the common duct of the telecom systems, and the orange one is the sewage system. So this is after our modification with the detections. Lastly, the conclusion. Taiwan Cabinet approved the forward-looking development plan last year. There are 6 development programs: green energy, digital technology, water environment, railways, urban rural projects, and so on. The aim is to connect the digital technology with all the infrastructures. And our company is also bringing all the new technology in the past few years, such as big data, LiDAR and UAV survey data, and the application of big model, just I mentioned before. We try to combine our design with smart technology. Our goal is to design smart and also to do smart design. Hopefully, in the near future, all the roads in Taiwan will be smart roads and all the city will be smart cities. This is the end of the presentation, and thank you for your time.
Thank you, Ms. Chiang, for joining us from Taiwan. Now, last but not least, Mr. Jae-ung Hwang, Senior Manager of Hyundai ENC, will be joining us on the stage, and he will talk about the practices of smart construction in expressway projects. Please welcome him with a big hand.
Good morning, ladies and gentlemen. I'm very pleased to meet all of you in this conference. I'm Jae-ung Hwang, and I'm in charge of BIM and smart construction in Hyundai ENC. I'd like to talk about the practices of smart construction in expressway projects. I will divide my presentation into 4 parts. The first part is our vision and capability of smart construction. As a global leading EPC contractor, Hyundai ENC has set up our long-term strategies and has been doing our best to lead the market based on smart construction. Currently, we categorize the 3 innovative tactics, such as digitalization, automation, and data-driven construction management, in order to achieve the efficiency, productivity, quality, and safety. Let me give you our track records for smart construction. Since 2010, we have proactively started BIM implementation in order to prepare for the digitalization of design and engineering works in the construction industry. Afterward, Hyundai ENC has been making the best implementation of BIM for many years. This is quite a famous architecture named the Qatar National Museum. Totally 70,000 atypical exterior panels could be designed, fabricated, and installed without any error by BIM implementation. And then we have successfully implemented the BIM to mega infrastructure project, the Sheikh Jabal Causeway in Kuwait. Total length is 36 kilometers, including the iconic cable-stayed bridge. We developed a full 3D BIM model to implement BIM-based engineering and construction management, such as design review, interface coordination, and so forth. In 2016, we started to research smart construction technologies in order to preemptively apply fourth industrial revolution technologies to construction industry. For the precise and effective earthwork management of large-scale infrastructure project, we have applied the LiDAR with drone and utility vehicles, also known as mobile mapping system. The acquired data of our digital twin model helps to analyze the earthwork progress without field survey works. In addition, project participants, including the employer, can visually inspect and survey the overall construction status anytime and anywhere without on-site visit. In order to facilitate the drone operation, we are developing and demonstrating the autonomous drone station that can be remotely controlled, including takeoff, landing, data uploading, and post-processing, as well as electric charging. In my opinion, machine guidance and machine control are the most innovative technologies that can directly improve the construction efficiency in civil engineering. Meanwhile, we demonstrated this technology can also contribute to eliminate dangerous field survey works, which are caused or struck by accident. Ultimately, we plan to develop the core technologies related to robotics, big data, and artificial intelligence in order to lead smart construction in global market. I will introduce the next item, some practices of smart construction in expressway bridge project. First of all, I'm prepared an interview of a beam manager in the Gold Grand Bridge, the world's longest concrete cable-stayed bridge. But the video doesn't working, so yeah, I will explain some characteristic practices in this project. Beam was used in the interferences checkup for complex and atypical reinforcements, such as pylon, pier table, and so on. And 3D construction simulation is also used for beam application in order to review and to optimize the construction schedule. And in addition, VR simulation was easily produced and implemented based on BIM model. So in this project, BIM-based VR and AR are implemented in various ways, such as pre-construction, construction schedule review, hazard identification, and so forth. Since the complicated construction process could be simulated with VR, reworks to be potentially occurred could be drastically reduced. While VR is used to plan and to review the construction execution methodologies at the virtual construction site before the actual construction started, AR could facilitate to inspect the actual constructed structures overlaid with 3D hologram displayed through the AR device at the actual construction site after construction is finished. Thus, these intuitive tools are expected to innovate the construction management process. Next, I will introduce our other items of smart construction in expressway tunnel project. There's no doubt at all that it's important for large-scale infrastructure projects to enhance collaboration. It is essential to operate the digitalized collaboration system involving a wide variety of subcontractors, such as TBM manufacturer, precast segment factories, and others. BIM-based common data environment is a simple and useful platform to share information for design review, interface coordination, real-time remote collaboration, and so forth. In addition, in order to review the mechanized construction methodology of the tunnel boring machine, VR simulation was developed in accordance with the specification and operation process of this machine. In the engineering phase, it was possible to minimize the design fault and to optimize the work process with safety based on VR demonstration. As a result, the entire EPC process of a tunnel boring machine could be improved without reworks in procurement and construction phase. When we analyzed the past performance of TBM operation for many projects, it was found that only about half of the allowance performance of TBM machine was used. Therefore, we developed an AI-based TBM operation guidance system that provides the optimal operation values based on the analysis results derived from the real-time measured data of sensors attached on TBM machine. Through this data-driven decision-making system, the operation stability of the mechanized construction equipment has improved. Lastly, I will introduce smart safety management solutions. Hyundai ENC developed an AI-based accident prevention system as a sort of smart safety management system. Accident prediction system is an AI-based risk assessment system that provides a risk assessment report and customized checklist corresponding with each work plan or permission to work. This system has been developed on the basis of the accumulated big data, more than 40 million data in various projects over the past decade. In the mechanized construction work, the most dangerous accident is a struck-by accident caused by heavy equipment. Therefore, various safety devices which raise the alarm when a person is detected are being applied. But most of them are turned off due to their frequent malfunction and misdetections. To overcome this problem, we have developed an AI-based safety warning device that detects only workers approaching within a certain distance with the advantage image recognition technology. We have also developed and deployed the unmanned safety management technology to construction site on the basis of robotics and autonomous driving technology. Our unmanned safety patrol technologies are expected to assist not only to prevent construction accident, but also to carry out the field management working, such as remote monitoring and online inspection on behalf of human beings. Until now, I have introduced the practical cases of smart construction on various expressway projects in South Korea. I hope that there will be more opportunity like this to exchange and to share the valuable information for smart construction. Thank you for your attention.
Thank you, Mr. Huang, for a remarkable presentation. Really appreciate it. Now we've gone through all presentations for session 1. So I'd like to thank all speakers for impressive and valuable presentations. Please give them another warm round of applause. Now, it's time to wrap up the first session of the 9th REAAA Business Forum. We'll have the lunchy break, which will be from 12 to 1:30. And after lunchy break, the session 2 and panel discussion will be followed. So we kindly ask all participants to come back no later than 1:20. Please enjoy your lunch, and I'll be back to you soon. Thank you. May I have your attention, please? The session 2 for the 9th Ali AAA Business Forum will shortly begin. So please take your seat and turn your mobile phone to silent mode. During the forum, simultaneous interpretation will be provided, so tune into channel 1 for Korean and 2 for English on your receiver. All participants and staff of the 9th Ali AAA Business Forum have been committed to complying with all government quarantine guidelines in order to prevent the spread of COVID-19 and help you enjoy a safer forum. So ladies and gentlemen, please keep your face mask on at all times. We appreciate your cooperation, and I'll be back soon. May I have your attention, please? The session 2 for the 9th REAAA Business Forum will shortly begin. So please take your seat and turn your mobile phone to silent mode. During the forum, simultaneous interpretation will be provided, so tune into channel 1 for Korean and 2 for English on your receiver. All participants and staff of the 9th REAAA Business Forum have been committed to complying with all government quarantine guidelines to prevent the spread of COVID-19 and help you enjoy a safer forum. Ladies and gentlemen, please keep your face mask on at all times. We appreciate your cooperation, and I'll be back soon. Ladies and gentlemen, welcome back to the 9th REAAA Business Forum. I hope you all enjoyed your lunch and also gained a fresh energy to keep on session 2. Now session 2 under the theme of Future of Road Engineering is about to begin. We have prepared 3 sub-subjects: BIM, the very first step of smart construction, digital transformation in construction industry, and convergence and integration of smart construction technology. Please welcome our first speaker of session 2, Mr. Alan Na, Executive Director of Hwaseng Builder PTE. Mr. Na will share how Singapore is doing in road infrastructure projects.
Good day, ladies and gentlemen. My name is Alan Na from Hwaseng Builder, or HSB in short. HSB is a local homegrown Singapore civil engineering contractors started by my MD, Mr. Thomas Ng, 30 years ago in 1992, starting from scratch to our current workforce of about 400 staffs. Over the years, we undertake all aspects of civil engineering projects, including golf course, construction of aircraft parking bay, taxiway widening, expressway widening, bridge construction, MRT viaduct and station, and vehicular tunnel construction. We have prided ourselves as a progressive company and over the years embarked on various smart technologies to aid our construction work. We have our own training center to train our workforce on various safety and health aspects with the aid of virtual reality room to simulate real work activity on site. We adopted electronic permit to work system to speed up permit application process, which can be time consuming. We also believe that a healthy and committed workforce is a strong workforce. We continue to engage the staff regularly and provide support to them so that they remain motivated and committed. Today, I'm both honored and excited to be able to share my experience on driving BIM and smart construction technology in Singapore roads infrastructure projects from a Singapore contractor's perspective. I'll share with you on the major challenges on Singapore's road infrastructure projects, give you a general introduction on how BIM comes into the field of road infrastructure and what makes it unique, and a glimpse of our project workflow adopting BIM and smart construction technology using the famous slogan of building twice, once in virtual, then in reality. There are three major challenges in Singapore's road infrastructure projects, namely 1, the existing underground utility services, the existing traffic condition, the proximity to residents and building while works are being carried out. Singapore has 733 square kilometers and approximately 5.5 million population. In a land-scarce Singapore, all our utility services, including our water mains, electrical cables, telecommunication cables, etc., are all buried underground to free up livable space and maintain pleasant aesthetic of the city. This has inevitably increased the complexity when construction work is to be carried out in a highly urbanized area. All the utilities are critical infrastructure and must be protected to prevent disruption to the daily livelihood of the city-state. Most of our road infrastructure projects involve widening of expressway, new link road through construction of vehicle viaduct, flyover, tunnel, or new arterial road for new towns. To prevent damages to these services, utility services plans are purchased, confirmed on site, and plot to the BIM drawings, overlaid to the permanent structure to be constructed. This will enable early intervention when clashes are detected in the virtual world to make adjustment to the permanent structure, and in the inevitable to divert these services away to make way for the construction. Diversion of these utility services are often costly, time-consuming, and destructive to the general public due to the shutdown of services, and is therefore imperative that the work is carried out safely without interruption to these utility services. There are 9,000 lane kilometers of road in Singapore, which equates to about 12% of our land space to cater for the approximately 970,000 vehicles. Therefore, it can be expected that working on this carriageway poses imminent challenges. Any unplanned shutting down of the carriageway will inevitably result in a slowing down of traffic, resulting in traffic jam and leads to frustration. Careful planning during the work is therefore critical to ensure that there are always lane-for-lane replacement when work needs to be carried out, or work can only be carried out during off-peak hours when traffic volume reduces. In a highly urbanized and matured city in Singapore, most of the road construction works are carried out in close proximity to residents or commercial buildings. Construction noise and dust generation is of great concern, especially in today's context when more and more people are working from home. Careful selection of smart construction equipment with low noise emission in conjunction with higher productivity machinery to shorten the work duration may be necessary to address this concern on noise and dust generation. In consideration of all the challenges that I have mentioned, we need to have more accurate information, location of such utility services, and surety to ensure that the work can be carried out with the least disturbance to the motorists and all the stakeholders around the construction, ensuring that there are no damages to the utilities during construction work. A comprehensive model incorporating all these challenges and constraints on site must be made available to the project team to have full visual when work is being carried out. This is when technologies come in play. to aid the construction work to be done safely with surety. As part of Singapore Land Transport Authority master planning to provide better road connectivity between towns and expressway, HSB was awarded a contract to build a vehicular interchange and a series of link roads connecting Punggol Town to Pasir Ris Town and provide faster connections to the expressway. When we embarked on the project, we decided to develop a BIM model for the entire bridge with 3D BIM. The drawings in PDF copy were digitalized from 2D flat drawings into 3D BIM model using Autodesk Civil 3D to capture all topographical survey of the ground in reference to the profile of the link road and bridges. The structural frameworks were then input into Navisworks with duration and construction logic to produce time-based construction program and sequence of construction. This sequence would then incorporate Google Map and statics photo to generate perspective, fly-through videos of specific work sequence using Lumion software for visualization. As the model develops, our structural consultant then input their structural element into the bridge details. Using a host of different 3D modeling software, including Revit, Tekla structures, this model develops the construction drawing and the reinforcement bar details. In consideration of the site and time constraints, major bridge components, including the bridge columns, piers, and beam, were prefabricated offsite. To ensure a perfect fitment between the precast component and the cast in situ structure done on site, our BIM model was shared with the prefabricator so that they have accurate information to ensure fitment on site. Using Tekla's structure software, bar bending schedule can be generated and shop drawings for precast component can be produced. As details are being developed, regular technical discussion and sharing of the BIM model to discuss the clashes detected virtually and solutions to overcome these clashes. These sessions are critical to ensure that this precast component weighing up to 100 tons can be smoothly installed onto the cast in situ structure on site without drama. The completed shop drawings were then shared with our in-house engineering team for evaluation and fitted virtually to the cast in situ element on site to ensure fitment without clashes. Using data from the Navisworks, the production line will adopt an DFMA technology to do a just-in-time casting based on forecasted launching date to reduce storage facilities and avoid double handling process to improve productivity. Virtual walkthrough using virtual design and construction software are then developed to build the construction sequence virtually. All different stakeholders, including the clients, launching specialists, precaster, and the auxiliary police are invited for the virtual walkthrough together with the project and supervision team. This ecosystem ensures everyone in the supply chain is clear on the actual process of the work and provides feedback on any risk or shortfall they may have observed during the virtual walkthrough. Once all the major foreseeable risks and clashes are addressed and resolved, the actual work progress can start without surprises on site. From our experience using BIM and smart technologies for our projects, we are convinced that there are notable time and manpower savings from using these technologies. The wide use of integrated BIM models to share across the entire ecosystem with all our stakeholders allow us to have better visualization and reduce error due to the use of wrong or obsoleted drawings. The integrated 3D BIM model were also able to layer the existing utility services over the permanent structure to be constructed, giving the project team more visual and allowing for proper planning in the services protection during work execution. This is important so that the disturbance to the utility services are kept to the bare minimum. The use of smart technologies, including sensor and artificial intelligence CCTV, further enhance the safety of these services. The use of virtual design and construction, or VDC, where construction sequences are detailed in animation, has the capability to view the actual construction sequence from all angles. to identify and deconflict any clashes virtually. Having building it once virtually, the project team can cut down the learning curve process on site and construct it on site more safely. The use of VDC also allowed the project team to plan for optimized site utilization requirement and reduces traffic diversion required for the work. In the event road diversion may be necessary to be carried out, the BIM model are able to work out the proper vertical and horizontal curvature of the diverted road with optimal site distance. This ensures that the traffic flow remains smooth and safe. Having the structural component manufactured in a controlled environment of the precast yard, we are able to eliminate long exposure of our staff working in harsh conditions on site, resulting in the intangible benefits of a safer working environment. With the reduction of cast in situ work on site, lesser dust and noise are generated. This results in a more bearable living environment while the construction work are being carried out. This will definitely lead to a more cordial relationship with the neighboring stakeholders, which are crucial when working in close proximity to these residents. Together with the use of VDC, BIM, and precast construction, we were able to significantly reduce time and manpower and completed the vehicular interchange and link roads project in Punggol projects up to 1 year ahead of schedule. The adoption of BIM and VDC has also enabled us to have better planning when we are tendering for projects. Using a host of software, we were able to envisage the methodology to be used and design out the risks. By eliminating all foreseeable risks, we are able to tender with more certainty and complete the project safely and timely. Looking into the future, HSB is committed to embark on integrated DFMA and integrated digital document management system to execute our projects in a more professional and sustainable way. The use of management software provides full BIM integration, QR code generation for all precast components, which can be used for tracking the production, delivery, and actual installation process. The management software with real-time progress updates can provide graphical presentation of actual progress versus planned work for easy visualization and progress reporting, which will further reduce manpower and improve efficiency in project management control. Once the completed components are installed or completed on site, the work status would be updated automatically in the baseline program to reflect work done. The use of such digital solution will greatly reduce the reliance of manpower for updating of work progress and improve productivity, while the project team can be better deployed for more productive and critical work activities on site. Over the last few years, information technologies improved leaps and bounds. With the rollout in the 5G networks, the impossible has been made possible. And while laying bricks and mortar remains, the methodology we use to do it can be streamlined and improvised, made possible with technology. Construction must not be the 3D that we know 20 years ago. Dirty, dusty, and dangerous should not be synonymous with construction. Rather, digital, dynamic, and desirable should lead the way. I'm excited to be able to witness this 3D transformation, and I invite you to join me to embrace this better, brighter, and breathtaking transformation journey together. Thank you.
Thank you, Mr. Na, for your presentation. Through your presentation, we could indirectly experience the road infrastructure projects undertaken in Singapore. Our next speaker, Mr. Yoon-ho Kim, CEO of Hanwha CNB, will be joining us on the stage. He will talk about BIM object breakdown, structure-based expressway, smart construction management, and case studies. So please welcome Mr. Kim with a round of applause.
Good afternoon, ladies and gentlemen. My name is Yoon-ho Kim, CEO of Hanwha CNB. First and foremost, I would like to extend my gratitude to REAAA officials for organizing this event. From now on, I would like to give a presentation on BIM project breakdown structure based Express Smart Construction Management and case studies. First, let me talk about the overview of BIM. Why do we need BIM technologies? If you think about the construction industry, the growth of technological improvement in the construction industry is rather slow, and labor productivity is quite low as well. In that sense, smart construction, blueprinting, and engineering automation is garnering attention from around the world so that we can focus on increasing productivity, efficiency, and scalability. Many different countries are coming out with their own plans to improve these areas. We, the Ministry of Infrastructure and Transport, came up with projects as well called Standard BIM guidelines for construction projects. And this includes basic guidelines for the future. And now I'm going to talk about the use of BIM in Korea Expressway Corporation. In order to go hand in hand with the utilization of BIM technology, we have been trying many different examples to adopt the technology. Among them, I can talk about one example of Taeyong Construction and Hanol CMB's Yangpyeong and Icheon Section 4 construction project. This is an exemplary case where the BIM technology was adopted successfully. And now I'm going to share the status of the Yangpyeong Icheon Section 4 construction project status. Yangpyeong Icheon Section 4 section is as long as 5 kilometers. There are 2 different tunnels. There is 1 exchange, and there is 4 different bridges. As we looked at the Yangpyeong Icheon Section 4 project, I'm going to talk about more specifics of the BIM technology. First would be object breakdown structure. This is the basic layout for the BIM object breakdown structure. First, we have 3D analysis, and then we add 4D elements such as temporal information and spatial data. And then the 5D information comes in, which is quantity and cost, so that we can manage individual object levels. And this is the process for the object breakdown structure. First and foremost, we have to analyze the domestic available data, and based on the analysis, we need to create the BIM-based construction OBS, and we then have to talk about cost and process information on top of that. And after that, you have to put in smart construction management pilot applications, such as processes and database management. Now I'm going to talk about the specific details for each element. So first and foremost, we have to specify object-specific modeling data, and then we have to define zonings for each project. And for figure calculation, we checked synchronized co-occurring information, and on top we defined historical information, history conversion, and quantity, and all the comprehensive information layers. And then we added them together so that we can only use object-specific modeling throughout the whole construction project period. And now I would like to talk about a sample construction that belongs to BIM object breakdown structure. So OBS has 7 different levels for categorization: road, process, facilities, direction, expansion, work zone, and sub-work zone. And for information mapping it will be managed with the sub-work zone management level. So based on these categorization, I'm going to talk about BIM designs. First is the civil area. For the civil area, we have terrain modeling data and elevation data and computing data as well. We also look at rock layer modeling, and on top of that, we have to make sure that scheduled and planning elements. As a result, we can create standard and corridor documents, and then we have to made it into a computer 3D solid modeling to make it into specific numbers. And then next is climbing formwork. We have to first define modeling level per object, and then you have to do object modeling such as bridges and pillars. And then we combine all the data as a 3D modeling file. And then next is a tunneling as well. Just like the bridge modeling, we have to define individual modeling level patterns. And then per pattern, excavation, lining, drainage, sewage, and opening and closing segments are all defined over here. And linear based information is put on top so that automatic object modeling is completed. I think what's important is automatic modeling and per pattern defining. And this is a specific video that describes the whole process. Number one is about bridge modeling. Next is tunnel modeling. Next is civil engineering modeling. We're not just doing the surface, but also rock layer modeling is being carried out. And by doing that, we can come up with an accurate calculation. Currently, we are changing the rock layer underneath through the modeling process. The next video is for after per object modeling, we're adding cost information on the top. This process is using the Vigo Office tool, and then we're doing automatic volume calculation through modeling. And per object, we are integrating process, pre-process, and post-process. And based on such design data, I'm going to talk about then how we utilize these data during construction. First is 3D shop drawing. Conventionally, we have been using 2D plans, and as a result, unless you are highly skilled, you won't be able to see the actual structure of the building. And because there are some parts that are hidden in the image, it was impossible to check what was inside. As a result, we needed a 3D map or blueprint so that all relevant officials can check what has to go inside. So if you look at Yangpyeong Icheon Section 4 construction project, we have a plan to submit 3D based modeling data and images. So, as a result, if you look at the 2D based conventional data or materials, now with the BIM based model, you can use multiple angles to see more accurately. And I believe that we will minimize the work and the time and energy that goes into the project. We can also help elevating the understanding of relevant workers who will be participating in the project. And now I'm going to talk about 4D process management. In the past, we only used text-based management system, and as a result, unless you're a professional or expert, you had to do it multiple times, which decreases decreases efficiency. And because you don't have enough understanding about all the materials that are required to be used for the project, the level of control is quite low. That is why we thought we would need a tool like this. So if you look at the Yangpyeong-Icheon Section 4 construction project, we mapped all the cost information for each section of the road so that you can have a visual hint of what the cost is going to be. Because there is data according to the process order of the construction, you can understand the overall project better and while identifying the risk factors. As a result, even for process management, in the past we were dependent on text-based process management, but it came visual using 3D model-based process management, and relevant construction workers would have a better understanding and better visibility about the project. And in the past, there was no integration between costs and the projects themselves, but now they're all mapped and tied together. And next, I would like to talk about 5D EV management. In the past, we utilized WBS-based EV per individual work unit, and we did a calculation afterwards. So we had to be dependent on human resources only. But the issue of this is that it was very complicated and the time to understand the whole project was quite lengthy, which was about 5 to 10 days. So every time we had to put in many different experts to get this done. As a result, what we did was we mapped price units per each segment of the construction project so that we can have a better visibility. So what we did was for each object model, we added individual cost of the item. And also for count extraction, we made it automated so that the count of the parts that are needed can be automatically coming out from the model. And when something short happens, then that specific part can be generated, and as a result, it would only take 2 hours to come up with a document about a specific part. So as a result, conventionally, we used the WBS-based historical record, whereas now we're using the OBS-based history record. And instead of using or depending on human labor, now we're using automated quantity calculation. It took about 5 to 10 days in the past, whereas now we're only using 2 hours, which led to increased productivity. And now I'm going to talk about the utilization of drones. The Yangpyeong-Icheon Section 4 project features many different drones at all times. So all section is now mapped as point data, and if you put in video data, you can come up with the size of the land automatically. And now this is the trend information of how the progress or the change is being made. And next I'm going to talk about the relations between BIM and roads. Once the land is cut, a drone would be flying at all times so that it can compare the BIM data that was registered in advance and compare that data to the real-life construction environment. Next is safety management. We can utilize BIM data to do simulation before you start the construction project, and all the participants can have discussions and provide feedback for individual processes. This is what we did as simulation before we embarked on the construction project in February, and according to the result of the simulation, we actually worked on the project itself afterwards. We also checked the timeline by running the simulation. This is the last page of my presentation, and I'm going to talk about two-way communication, which is a CDE platform. For efficient project management, we have utilized CDE. We use Veeam 360, ProjectWise, and Connect. We analyzed all three options, and they didn't allow us to do process management. As a result, for the first time here in Korea, we utilized a system so that vendors, subcontractors, and the initiator of the project can come together in one platform to share relevant information. So among construction parties, you can build a collaboration system, you can minimize risks and maximize productivity, and the development was undertaken with that purpose. Thank you very much. This is the end of my presentation.
Thank you, Mr. Kim, for your remarkable speech. Your presentation helped us well understand the importance of BIM-based projects. Now we'll move on to the second theme of session 2, digital transformation in construction industry. We invite Ms. Kei Sasaki and Ms. Ing-Lei Shue from Taisei Rotec Corporation, Japan. They are joining us online to present efforts of visualization technology using ICT.
Hello everyone. Now, the presentation is about efforts of visualization technology using information and communication technology. For introduction, Japan currently is facing the historical turning point due to lower population, fewer children, and aging society. During this condition, to achieve the sustainable growth of the economy, it becomes a severe problem also in construction sites for rising productivity. From this background, Taisei Rotec becomes focused on the research development of using ICT technology for labor saving, visualization, and improving quality management. Here, about two technologies will be introduced. Number one is the research for road earthwork or subgrade compaction management, in which Soil compaction can be measured by non-descriptive and area means. Number 2 is for visualizing underground objects by using HoloLens from Microsoft and BIM model, in which prevention of damage to underground objects and improvement of work efficiency can be possible. Now, it is about upgrading quality management and labor-saving technology by rolling type RI device. Currently, compaction management in the road art and subgrade construction is performed as quality control defined in MLIGT, Ministry of Land, Infrastructure, Transport and Tourism. Generally, RI device or shunt replacement is used. In the test method, after compaction, the places are first determined and measured. Since the management is based on points, there may be concern of overlooking inadequate compaction places. Labor work is demanded to drill holes, so there needs at least one person as QC staff to do the test, and many lower postures required to do the work in the site, which are easy to be hidden in the blind spot of heavy machines. And so, serious accidents like collisions may occur. The next thing, after shunt replacement test is completed in site, moisture test is performed in the lab. It takes about 1 day to get the result for the shortest. It probably needs to redo the work in case of unsatisfactory result. Here, time lag is found. To solve the problem, by incorporating 3 companies, Taisei Rodec, Taisei Kansetsu, and Soil and Rock Engineering are doing the research of TI compaction as the technology of upgrading quality management and labor saving in compaction in road or pavement construction. As shown in figure, rolling type RI device is built in the vibration roller. While running on the ground, surface in contact, compaction rate can be measured automatically and non-destructively. And it is managed with location information from built-in GNSS. Rolling type RI device includes density and moisture meters of cylinder shape. The principle is the same as scatter type conventional device. Calculation is made for every 3.3 square meter and can measure with high density. Now about the applicability. MLIGT is implementing the project, named as a project related to the introduction and utilization of innovative technologies that dramatically improve the productivity of construction sites by using PRISM budget. In this project, the technology proposed by our consortium, found with 5 companies, was adopted. Then, measurement of compaction rate in subgrade construction was performed by TI compaction. And from the result, the construction was attempted. The outlines are like that. The site was 2020 Midono North District PP pavement construction, ordered by Chubu Regional Development Bureau. Construction type is subgrade construction M30. About 2,850 square meter was measured in 5 days. Then, for accuracy verification as well as necessary correction of rolling type RI intensity and moisture meter, field density tests were also carried out at system places by shunt replacement method. Please watch the video of measurement. In TI compaction, the compaction rate can be measured while the vibration roller is running. The operator handling the measurement device. The density and moisture content can be measured with the rolling aura interface. The recess can also be checked during operation. Then, the data being shared with cloud system and accessed from everywhere. The merits are like that. Compared to the conventional method, higher density of measurement is possible, and because of area measurement, overview of inadequate places is avoidable. Increased safety for not requiring any person to be inside. Cut labor saving because the operator of heavy machine can do the compaction measurement. By grasping the measurement recess in real time, actions can be taken as necessary and effects, improving construction efficiency. Now it is about underground visualization technology by using HoloLens and BIM model. MLITD is promoting utility pole removal from the standpoint of farming good landscape and improving tourism, keeping safe and pleasant passages, reducing road disasters. According to the plan for promotion of utility pole removal formulated in 2021, the goal is to complete in all emergency transportation routes in urban areas where there is risk of electric pole collapse by 2050. In electric wire utility tunnel method, it requires to confine the ledger, which registers underground or buried objects, and do trial digging. There are some issues with this, such as 1. Time and labor requirement in trial digging. 2. Not always believable in underground object ledger. 3. Accidental damage to underground objects. From the above points, number 4, construction efficiency is not so good. The introduced technology uses HoloLens from Microsoft. By importing BIM model data in HoloLens and by matching marker displayed from HoloLens and the reference point of sight, the visualization of underground objects and pavement is obtained. The measurement accuracy depends on reference matching. The error may come out in centimeter unit in the smallest. But the person who wears HoloLens can see the site in real and 3D images of buried pipelines in combination, which means mixed reality MR. Next, about applicability at construction sites. Taking the advantage of electric wire utility tunnel construction in one national road, which requires not to damage underground objects like electric wires or communication lines, safe and accurate installation, we consider to use effectively 3D BIM model and ICT in this construction. The project is ordered by Kim Ki Regional Development Bureau. The construction length is 185 meters, containing 7,110 meters of pipelines in total length. Practically, first, existing underground objects are acquired non-destructively. Then, 3D CAD model from the data and 3D design data are combined together to develop BIM model. With this visualization, design consideration can be done effectively. Next, in pre-surveying, underground objects are acquired by ground-penetrating radar, and point cloud data above the ground are found by terrestrial laser scanner, named Focus from Focus Company, as ground-penetrating radar (GPR). Hand-push type antenna radar is used, a skill card made from Geoscience Company, in which area data can be obtained. The performance of devices are as shown in tables and the condition of measurement as in the photos. The accuracy of hand push type antenna reader is about 10 cm vertically or horizontally, but the accuracy can be improved by calibrating the position of known values like manhole and so on. And point cloud data above ground can be combined together to get more precise. The conventional drawings, like plans or sectional drawings, are complicated and require skill to confirm the pipeline location. But here, point cloud data and 3D pipeline models are used to develop same model with attribute information. Visualizing the data above ground, underground, and design in one 3D map makes clear to know the existing and new pipeline positions. And thus, before excavation starts, plan and revision can be checked well for pipeline interference from the design stage. As said earlier, pipeline interference can be checked on PC. In front-loading process, design can also be revised as necessary before construction. This helps for smooth consult with the client. In this construction, intelligent machine-controlled power shovel made from Komatsu company is used. Since the location can be detected from GPS and many sensors to assist the operator, excavation can be done well along the surface respective to beam model. Now to consider the construction efficiency. It took 48 days for beam model development in this technology. But 46 pixels of interference, which were difficult to know with the conventional method, were confirmed in this method. So it prevented the reconstruction work. It will take 84 days for reconstruction with the conventional method. But by using beam model, it took 0 days. As well as by using ICT with visualization, it saved 12 days. So 48 days were totally reduced. As the construction time of 220 days was reduced to 48 days with this technology, the construction rate is 22% up. Next, with HoloLens with MR visualization, the operator can aware the position of underground objects and conditions. Easily notice the buried objects in the excavation area and prevent damages to the objects. With the CIM model imported in ICT machine, over-excavation can be prevented. It relates to the prevention of damages to buried objects, and safety is also improved by reducing manual excavation or inspection. Finally, as future plan for ICT technology. Currently, Japan has problems with declining birth rate and aging population. So in future, by using ICT, it is aimed to contribute the society with innovative methods and sustainable development. Thank you for your attention.
Thank you, Ms. Sasaki and Ms. Chue, for your thoughtful presentation. Really appreciate it. Our next presenter is Mr. Seokjun Yoon, Principal Research Engineer of Hanmek Engineering. His speech is about turning engineering into digital reality, a vision of the future construction industry.
Thank you for coming to my presentation. I'm Seokjun Yoo. I'm a research engineer of Hanmek Engineering since 2017, working in the field of software development. I guess many of you are less familiar with my company, so let me introduce it shortly. Hanmek Engineering is an infrastructure design and engineering firm founded in 1996. It has designed many highways, bridges, and tunnels in South Korea. It is rather a small company in terms of its revenue, which is roughly $36 million in 2020. Actually, it has 4 sister companies, some of which earn more money. Its sister companies include another design and engineering firm, 2 precast concrete fabricators, and 1 environmental engineering company. The main topic of my presentation is about digital transformation of the infrastructure design and engineering, especially using digital twins. This presentation has 5 sections. The first section shows the problems that need to be solved with digital transformation. The second section discusses on our vision of the digital transformation is the future of the infrastructure engineering we see. The third section describes the components that forms the digital transformation. The last section discusses the things that need to be done to realize the transformation, plus a brief description of what my company is doing for our digital vision will be given. Section 1 on problems. One of the reasons why we are focusing on the digital technology is because the traditional engineering techniques are not sufficient to keep the civil and infrastructure engineering competitive. As you look at the left side graph, it shows the productivity trends of construction compared to manufacturing and other economic areas. According to this graph, construction ranks the lowest, and its annual trend is not really impressive. Low productivity is deemed a financial trouble for the contractors, and it also causes great concerns in terms of public safety. From the experience of other industries, low productivity seems to be caused by low level of automation. Qualified technicians are scarce today, so if automation is not sufficiently employed, the quality and the safety of the infrastructure will be in danger. I also want to mention some South Korean specific issues, though I suspect that other Asian countries have similar issues too. Population aging, for instance, seriously affects South Korean economy. More money needs to be spent for taking care of the elderly people, which causes reduction of new infrastructure investment. Also, as many skilled laborers are aging now, they are retiring without a new supply of young workers, which is detrimental to the industry's future too. As a result from the tightened budget, there will be fewer new infrastructure projects, and the business competitions to get the project will be tougher. To survive those tough competitions with extra public benefits regarding safety and more, smart construction came up. Section 2, vision. Our claim is that low productivity can be improved by automation, and information technology plays a key role in the automation. We call it smart construction because the automation powered by the information technology makes the traditional construction engineering smart. Of the smart construction, there are 2 aspects, hardware and software. When we build a physical structure like a bridge, we use various machines and tools, that's hardware. For smart construction, robots and equipment automation are the examples of the hardware aspects. On the other hand, when we design the bridges before we build it, we perform intellectual tasks such as analysis and calculation, often with soft computer software. For engineering firms such as my company, software aspect is the main focus area of smart construction. As all of us have experienced, many parts of our everyday life have been digitalized. I think that such digitalization has been done incrementally for decades. When I was a kid, video games took over kids' playground somehow. When I went to college, personal computers running word processors replaced notebooks and pencils. Not long after that, every engineer was using CAD for drafting instead of T-squares and triangles. Such transitions still continues today. Digital transformation is pushing such change forward, the point where synergy is achieved by advanced software systems and by integrating them. combined with networking, advanced digitalization that allows further innovations, not only for the technologies, but for the business processes and the way we understand them. Let's talk a bit more about digital transformation. Digital transformation implies a fundamental change of existing business practices. For civil and infrastructure engineering field, we see the transformation will be implemented by digital twins. Digital twin is a precisely duplicate virtual world where civil infrastructure can be built, measured, and demolished. Events that happen in the real world infrastructure can be duplicated in these virtual twins too. Simulation in the virtual world against the digital twin is the key for making such a synchronization possible. From the perspective of digital transformation, digital twin has several advantages. The stakeholders of the infrastructure can communicate over the virtual world with it. The virtual world can overcome the spatial and temporal limitations of the real-world communications. Therefore, digital twin allows us to innovate how we work. Section 3, components of digital transformation. Now let's dig in a little bit about how to implement such a digital transformation. Just as I said, digital twin is a key to the transformation of the construction industry because digital twin technology can address various lifecycle management issues of infrastructure. When we implement the digital transformation based on the digital twin, it will consist of 3 key components: data model, software, and service platform. First, a data model. A data model represents a real-world existence for a concept into a structured data format. Virtually, all computer systems that handle the real-world phenomena, from bank ATM to power plant controllers, need such models. Therefore, the data model can be seen as a gene of a digital transformation. For digital twins, the data models are rendered into visual elements showing their shape. For computer software, data model is crucial to its functionality. There are many different kinds of engineering software for design analysis, cost estimation, and more. The software can recognize the digital design because data model provides the vital information of interpreting the data. As digital transformation applies to the entire life cycle of the infrastructures, its data models will evolve as it goes through the life cycle stages. However, even each stage requires different data, they share common data elements, which need to be clearly defined in the data model. Second, software. The second component is software, a source of digital transformation. The data model defines what the infrastructure is. Such a definition is done by an engineer using software. To achieve the higher automation level, there must be a new breed of software that caters for the new digital twin-based business process. The new software must satisfy the following features. First, it must help the user handling higher precision and large volume of information provided by the digital twin models. Typical human engineers will have difficulties in handling them manually. Second, it must provide a certain level of automation for the task it is used for, although full automation of engineering design seems a dream for now. But automating basic tasks such as document generation will still be helpful. Third, it must embody the business knowledge and process that are needed for the engineering. Such knowledge needs to be captured to the software. This requires close collaboration between the engineers and the software developers. The last component of our digital transformation triad is a service platform. The platform is a special kind of software which provides online service to its users over a network. It's called a platform because the service may target other client software and serves as a common component for the software. For our digital twins, the platform hosts the data model and manages the data collection based on it. The collection includes the core data components of the digital twin, which is shared by multiple stakeholders throughout its life cycle. Also, a data collection which is specific to an individual stakeholder or a certain life cycle stage is called a model view, is also served by the platform. For digital twin-based life cycle management, its service platform must provide two key functionalities. The first functionality is to manage the simultaneous access to the platform. Also, it should manage the interactions between the users. The second functionality is to manage the change of the data collection. As multiple changes occur simultaneously, they have to be coordinated to avoid any conflicts. Also, history of the change should be kept so that they can be tracked down later or cancel them if needed. Section 4, changes. To this point, we have covered what the digital transformation is and its main ingredients, which is implemented as digital twins. Now, I'd like to discuss the changes as a result of the digital transformation. The biggest change we see is that the virtual side of infrastructures will be more visible to the stakeholders and more business will take place in the virtual side of they are now. For instance, the digital twin of existing condition, as you see in the upper left side of this slide, allows pre-construction planning in the virtual world with the benefits of advanced visualization and better software support. In this virtual world, the digital twin model's behavior will precisely simulate its physical twins, including its interaction with people and equipment. Software made for the digital twins will provide the real-world-like user experience for its synthetic work, combined with the visualized parameters and the analysis results. For the contractors, the construction process will become more like reconstructing the virtual model components in the physical world. New automation technologies such as computerized prefabrication, large-scale 3D printing with advanced material will enable automated reconstruction of the virtual model. If the design and engineering phase, the design alternative can be virtually built and simulated until an optimal alternative is found, which means virtually the designer will have to do many of what contractors do now for the physical construction. The biggest change will happen to the scope of the designer role in the life cycle of the infrastructure. This virtual world allows broad involvement of the designer because she has actually constructed the virtual model. If the model is synchronized with its physical twin, many of the maintenance work such as monitoring will be possible within the digital twin. Such change also implies some challenges. One of them is that both quality and quantity of the information produced by the designer will increase and well beyond what current business practice expect. The designer must be capable of dealing with the information at the early stage of the project. Possible solution for this change is automating the design and engineering process, which is done by the intelligent software. Making the intelligent software means that such software is a professional knowledge needed for generating design and engineering information, which is realized by capturing the know-how of the individual and an organization of the design and engineering business. Therefore, for the design and engineering firms, the capability of capturing the professional knowledge and possibly packaging the captured knowledge into the intelligent software will become more important. Section 5, things to do. Now, the final section of my presentation. Here I will cover key technological developments, organizational and industrial readiness that to be achieved. Key technologies for the digital transformation, including digital twin, have been available for years or decades. However, some of them need to be more mature. For instance, 3D scan technology still has room to improvement, such as accuracy, scanning speed, blind spots, etc. For modeling the virtual world and the infrastructure, large-scale modeling is still an issue, but the technologies for handling the geometry are advancing now. More important thing than the geometry is to create an information model which can hold vast areas of information from all the aspects of the infrastructure lifecycle. Making such a model is difficult because many of existing business practices haven't been digitalized and some of them are hard to translate digitally. For example, budgeting and scheduling tasks. Maybe the tougher part is capturing the design and engineering knowledge and packaging them into the intelligent engineering software. Recent advancements in artificial intelligence, such as deep learning, may give some clue regarding for this, but traditional knowledge bases or even programming languages may also provide the solution if the communication between the engineer and the software developer is frequent and well organized. For hardware-wise, such as robots and machines, many issues have to be solved to make a breakthrough. However, I'm not covering the hardware stuff here, which is well beyond the scope of this presentation. As we already have experience in personal and mobile computing areas, when some technological advancements have been made, cultural and sociological change also follow. With the digital transformation for the civil and infrastructure engineering businesses, organizational and cultural change will affect the entire life cycle of the infrastructure afterwards. What we see is the change will be more fundamental to the existing business practices. The expansion of the designer's role and better accessibility to the digital twin platform for the stakeholders, the boundaries between the stakeholders, as well as the ones between the business areas will be blurred. Also, technology will change the business processes of the industry. Such changes have always occurred as new technologies become available. However, preparing for such changes in advance will be helpful if it gives competitive advantages. So the bottom line here says respond proactively rather than reactively. Now the last slide. In this slide, I'd like to cover briefly what we are doing at HANMEC Engineers Tech Development Center. The center was started in the early 2010s as a small group of engineers and software developers to implement intelligent engineering. These early efforts are tied into our internal needs, such as drawing management and document generation. However, we are now moving toward their twin-based digital transformation. Here are some highlights of our development efforts. First, the models of topographic information and GIS in-house model processing and viewing modules are being developed. The geographic modules can interpret with our engineering modeling software, so the virtual structure can be shown on top of the virtual terrain information. The model of the roads and the structures are generated based on the logics developed under close collaboration between our civil engineers and software developers, allowing the engineers' expert knowledge to be captured into our software. For simulation, the simulation capability of the digital twin, structure analysis module, and construction simulation modules are under development. Realistic visualization capture capabilities supporting virtual reality and extended reality have been implemented to support the digital twins. Also, a part of government-funded smart construction research platform technologies for sharing the digital twin models are under development, which includes their standards and common data environment for the precast concrete product delivery. Okay, that's all. This concludes my presentation, and I appreciate all for joining me. Thank you.
Thank you, Mr. Yu, for your great speech. It was a very meaningful talk that led us to the world of digital reality in construction. Now, let us move on to the next subject, convergence and integration of smart construction technology. The upcoming speech will be given by Mr. Wei Shen Lee, Secretary General of National Science and Technology Center for Disaster Reduction, Taiwan. Mr. Lee will talk about rising opportunity for engineers to cope with impacts by disasters through innovative and smart approaches.
Chair and dear online participants, today I'm honored to share some experience of Taiwan. I'm Wei Shen Lee, Director General of National Science and Technology Center for Disaster Reduction. My topic today especially emphasizes how we mitigate kind of impact by disaster through innovative and smart approach. As you know, Taiwan is facing a lot of challenge from natural disaster. Among the all, I think typhoon and earthquake are two devastating disasters to Taiwan. Today, I will use one example to emphasize how we used innovative and smart way to mitigate impact when we have the typhoon. As you know, there are so many things related to resilience, but an international insurance company, Maplecroft, published a report in year 2013, identifying if considered about social economic resilience, Taiwan is at the leading position around the world. You see here, I think both Taiwan and Korea, Japan are listed at low risk. I will summarize the major factors that leading to low risk and high resilience in Taiwan. I think first of all, application of science and technology, like my office. Another one, we keep risk transparent. So this is the major topic I'm going to share with you today. First, I will give a little background information about my office, National Science and Technology Center for Disaster Reduction. My office is directly under supervision of Ministry of Science and Technology Taiwan, and my office is an interface to apply science and technology for disaster risk management. So at my office, we include different background of discipline related to disaster, no matter from the natural sciences all the way to business management. And our major mission is to provide a lot of services like science and technology transfer, science and technology innovation, database and knowledge base, and international collaboration. And we have a lot of products. Even during emergency operation, we still have roles working at our Central Emergency Operating Center. But our job is not about search and rescue. And also have some international partner. Likewise, in Korea, we have a good partner is MDMI. And I would like to mention about one trickling point in Taiwan. Why my office played important role in disaster management in Taiwan. I think it was the Typhoon Morocco hit Taiwan in 2009. The single typhoon bring up to 700 people die, especially in the Xiaolin township in Kaohsiung City. 400 people were buried alive after a huge landslide. That kind of big pressure in Taiwan, we have to improve our disaster risk management system. After reviewing kind of the setback by Typhoon Morocco, we summarize some major points we have to improve in information part. First, too much or too little information at emergency operation. In 2009, we already have a lot of information system, but the problem is we don't have the system to integrate information. So my office received a job assigned by our government to collaborate with a lot of partners, especially from the public sector, to build a system to integrate information, because we also find we lack common operational picture to coordinate action. So we need kind of the good situation map to coordinate all the key stakeholders during emergency operation. Another one is how we support decision-making process. Later, I will use one example to show how my office uses information intelligence to support emergency operation. And the most important part today, I'm focused on information intelligence. We call it a very important part. Through the cross-cutting synergy, information sharing and action. Currently, my office, we collect more than 450 big data sets contributed by 40 more agencies, including public and private sectors. Most important thing, why we collect a lot of information? Because we want to produce information intelligence to reduce possible impact. So very important thing, we not just collect data, we not just create database, we not just bring information, but very important thing, we hope our services can create some action and application. Later, I will tell how my office used the modern ICT technology to share information to the or stakeholder in our society, especially one product I think also very popular in Korea is Line. I will use the different channel to enhance information coverage in Taiwan. And before I go in further detail, I have explained about disaster management framework in Taiwan, especially as central government. As I mentioned, my office directly under the most Ministry of Science and Technology. During ordinary day, if no disaster, NCDR plays a role as the think tank to our government, like what is good policy for disaster risk reduction. What we can find some the insufficiency part in Taiwan about disaster risk reduction. But in case of emergency like earthquake, like flood, like typhoon, NCDR will join with other government agencies at Central Emergency Operations Center to respond to the situations. So in the CEOC, Central Emergency Operations Center, NCDR is take the lead of one group in the EOC. The name of group is Situation Assessment Group. In this group, actually, NCDR will collaborate with a lot of government agencies, like Water Resource Agency, provide a lot of the hydro information. National Fire Agency tell us a lot of situation, especially some medical demands. And Highway Bureau, of course, provide a lot of information about road closure or any impact to the highway system. And Soil and Water Conservation Bureau provide parameters related to debris flow. And Central Weather Bureau provide us a lot of parameters related to typhoon. And when we reach some conclusion, we will have Office of Disaster Management under the cabinet level to disseminate information to the local government, even to the general public. So in Taiwan, integration is very important part. My office actually integrate with a lot of government agencies in case of emergency. We will work at the EOC. Actually, my office is in the same building. We will have the situation assessment group meeting and the big meeting to share our finding. And the most important thing, we have to provide a lot of information related to emergency, like how science can help the emergency operation. I will divide into the four major impacts during a typhoon. From the wind parts, wind damage, storm surge. For a torrential rain, could be flood or landslide. We have to answer some questions that can help emergency responders about when, where, scale, and scope impact. By information we pass to emergency response, they can do some pre-disaster deployment, like the Army can help evacuation, or like the Water Resource Agency can deploy some equipment. Even the Highway Bureau can do some road closure to reduce possible damage or the casualties. I will use one example to tell my office duty during the typhoon. This is the example of last year during the typhoon Changshu. And my office will use kind of big picture to identify possible impact by typhoon. And most important thing, we use a lot of the big data and the real-time data to show commander about current situation. Like this one, you can see we can collect several real-time rain gauge combined with the radar image and satellite image, and also show rain distribution. It's kind of current situation. And the most important thing is we will give information into different phases. Like usually we are talking about at approaching phase, impact phasing, and departing phase. At each phase, very clear, we must give kind of scenario, time-dependent factor, and the possible impact. Like this one, we highlight at approaching phase about its impact by rain, and we estimate about how much rain it have, and also estimate its risk. Likewise for the impacting period and the departing phase. And except by rain, we also estimate about impact by strong wind. This picture also shows the strong winds impact during a different phase, as I mentioned, 3 different phases. And we also tell about the possible impact by high tide. And this is our model based on the movement of typhoon. We can highlight about when and where could suffer the high tide or storm surge by the typhoon. And very important, I mentioned my office integrate a lot of information, especially a CCTV camera. This also very important. We can observe the real time of tide movement like this one. This is highway, this near a train station. So combine a different source of image, we can convince the commanding officer in the EOC what kind of action or response they should make or take. And also about the risk of flood. From the chart, you can see we also emphasize three different phases. By each phase about is the risk of flood and where could be the hotspot of the flood. Another very important thing, because the 70% of Taiwan is in the slopland area. So in the mountainous highway, usually our focus during the emerging response when we have typhoon, because road interruption might lead to isolation to some the community in the mountainous area. So based on our past experience and some model, we also highlight the possible area to suffer kind of landslide or kind of road interruption during the period of typhoon attack. And we also have to highlight like this one because a few days ago, there also an earthquake hit the east part of Taiwan. So we have to often remind the people about because of earthquake, it might further trigger some landslide. And another very important thing, we create kind of network, we call it N to 1 and 1 to N. We collect a different kind of information, we call it kind of end-to-end connection. Based on the citizen, based on decision maker, we can deliver their demands information intelligence so that they can take action. We can fill the information gap. And this is very important. We create kind of the web page system, not just for the emergency responder and also for the general public, they can receive information. But in Taiwan, how we achieve information sharing, I think after Typhoon Morocco, the first step we have taken is the policy of open data. So we create a platform. We introduce the common alerting protocol to standardize all the disaster data, especially information for exchange, kind of the common and the national standard. Then we collaborate with Google. We share information on the Google platform, a kind of win-win situation. And since we launched the service in 2013, every year over 50 million people received direct benefit from the Google system, but we never set up a system like this. So later we use CBS. We also use CBS to send information on user cell phone, including kind of the roads closure. So this is how we use the smart and modern technology to increase information dissemination to the end user. And line, because most of us right now we use a cell phone. We think line is the good channel we can disseminate alert to everyone in our society, especially location-based. So we start kind of collaboration with line in 2018. In the 4 years, 1.2 million users more to subscribe our service. Wherever we have any situation, we can push information to user cell phone. So very important thing in Taiwan, we emphasize several elements for building resilience is the data, information, knowledge, wisdom, and action. The fundamental part is still science and technology. We know the limit of science because no perfect model. However, through the real-time data, we implement the step to have the data and information. But very important thing, based on our scenario, risk and evaluation in recent years, we create a lot of knowledge and wisdom. But very important thing, because we work with emergency responder, so we can help decision making and application. So that is very important thing. In Taiwan, we fully follow the idea about from data, information, knowledge, wisdom, and action. And the key reason and element led to succeed, we integrate all kinds of sciences and technology. And we also evaluate the new emerging technology can help us. So thank you for your listening. And if any question, please X later or send me an email. Thank you very much.
Thank you, Mr. Lee, for your speech. It is really meaningful presentation, especially when disasters are growing all around the world. Our last speaker of session 2 is Mr. Danis Sumadilaga, Head of Construction TF for New Capital City, Ministry of Public Works and Housing, Indonesia. Mr. Sumadilaga will share his insights into the new capital city of Indonesia.
Hello, good morning everybody. I hope everybody are well today. And thank you for giving me the opportunity to present about new capital city of Indonesia and smart construction technology. I'd like to start with the urgency of relocating the capital city. As you may already aware that our president, President Joko Widodo, has announced that on August 18, 2019, has taken a very important decision to relocate the capital city of Indonesia to East Kalimantan. There are several aspects that encourage the decision. First are about disperse the population more evenly across the country. As you may aware that around 50% of Indonesian citizens are located in Java Island, with approximately 150 million people located in Java Island. But the most important thing is to increase the economic growth outside of Java. As you may also aware that Java economic's contribution is almost 60% of the national GDP. Others is we try also to avoid the clean water crisis in Java, especially in Java, East Java, and also in Jakarta. Also, we are considering about the high rate of land conversion in Java. Also, we also considering about the concentrated urbanization in metropolitan Jakarta, which causing in high traffic jam and air pollution. Also, we try to avoid a decrease in carrying capacity and high level of economic loss in Jakarta. But also considering about the potential of dangers on flood, earthquake, and land subsidence. That is the urgency of relocating the capital city. Second, we are trying that the new capital city is directed as a catalyst for East Kalimantan by encouraging the future economic development through collaboration between two main capital cities in Kalimantan, Samarinda and Balikpapan, created what we call it urban city triangle as a super hub. Each city has special role in economic sector to encourage a rising in East Kalimantan gross regional domestic product. We have a vision for our new capital city. So following those reasons, Indonesia's new capital city aims to be the most sustainable city, an economic driver city in the future, and as a symbol of national identity, as well as a catalyst by encouraging future economic development. This is the location of new capital city. As you may already know, new capital city is located in East Kalimantan province and divided to several areas, mainly government core area known as KIPP, and consists of area west area, east area, and others area. To achieve those vision, mainly the most sustainable city, capital city is planned to have many green open spaces, and developed by clean and sustainable energy. Now we are talking about the government core area. To create capital city as the catalyst of improved Indonesian human civilization and as a symbol of transformation, capital city should comply with these three main criteria that should be translated innovatively in urban design: reflecting national identity, assuring urban sustainability, and creating smart metropolis. The total area of a government core is approximately 6,600 hectares, consists of various zones of mixed-use neighborhood, including government building, national security and defense, and also office and commercial area, with total population estimated more about 150,000 people, depending on housing capacity. And then, what is the urban design principle for the government core? The development of the capital city will prioritize as a future city model that is planned and designed as smart, innovative, and inclusive. But also, infrastructure and urban development aspects should comply with global principles, national and local wisdom, and nevertheless, with tangible KPI to achieve the vision of new capital city. Alongside with those criteria, 9 big moves and 5 transformation create KPI as a baseline to plan and design the city by forming a built environment. In designing a capital city, also guided by 5 cultural transformative aspects, which are preserving nature, nationality, living, mobility, and working. All those transformation and KPI value will be accomplished gradually in the development of government core area. For the initial stage, we have infrastructure development. First, the development of urban infrastructure will consist of targeted land development, priority office buildings such as presidential palace and government complex, housing for government employee, and other basic infrastructure like road, water supply, sanitation, drainage system, and others. And smart city concept for capital city in urban and infrastructure development should be positioned to improve the quality of life and enhance the productivity of cities while protecting the environment by utilizing ICT innovation. Smart technology is applied to implementation phase, but also in planning and design phase, such as using an integrative urban planning and building system application. Urban design and engineering process for new capital city using the principle of collaborative work by utilizing and integrating building information modeling and geographic information system model ecosystem. For smart construction, real-time monitored construction process, document management, and design construction approval. In order to fulfill the smart concept that previously mentioned, the road infrastructure in new capital city is planned to be built with an immersed tunnel in one of the toll access road, as well as providing charging lines and stations within the city. Other proposed smart technology on urban infrastructure. Several smart urban infrastructure will be built in the context of optimization and integration through ICT technology, including integrated sanitation, urban domestic, wastewater management, integrated flood control management, monitoring on environmental condition, and also multi-utility tunnel containing utility lines. As a closing, smart concept for infrastructure and urban development cannot neglect the principle of sustainable development, and that will bring those development to achieve new capital city vision to be the world-class city for all, to improve the value of people's life, and to preserve the environment. The nature of smart city concept is interrelated element in which for its implementation needs inclusive participation from all stakeholders and including community and accommodate innovation ecosystem. Thank you.
Thank you, Mr. Smadilaga, for your wonderful presentation. Ladies and gentlemen, thank you for your attention and engagement so far. Now, we'll proceed with the panel discussion. The topic of panel discussion is smart construction technology and new business opportunities. The discussion is chaired by Professor Sung-Han Shim from Seongkyungwan University. And also, let me introduce today's panels. Dr. Sungmin Michael Jo, Director General, Center for Smart Construction Technology at Korea Expressway Corporation. Professor Spout Malai Krisanachali, Associate Professor and Head of Department of Civil Engineering at Kasetsat University, Thailand. Professor Chong Won-seo, Professor of Department of Civil and Environmental Engineering at Hanyang University. Mr. Alan Na, Executive Director, Hwaseng Builder PTE, Singapore. Mr. Gildam Satria, BIM Manager, PT Vaskita Karya TBK, Indonesia. Mr. Sung-Hoon Kim, President and CEO of Taesong SNI, Korea. Ms. Lidwina Wardani, Ali AAA Business Forum Coordinator, Indonesia. So, Professor Shim and panels, please come up to the stage. So, I will hand over the floor to Professor Shim. Professor Shim, floor is yours, please.
Okay, thank you for the introduction. Again, my name is Sung-Han Shim, Seongkyungwan University in Korea. So this is a great honor for me to chair this the panel discussion with the greatest leaders, the people in the field of smart construction technology here in Korea as well as in the world. So with this, the leaders in smart construction technology, today we'll discuss three very important topics in smart construction, including smart construction and its significance and potential. And second, current development and highlights. And lastly, we're going to talk about how we can foster the smart construction in our countries. Okay, so actually these topics are very important. So maybe it will take the hours and days to fully discuss all these topics. But we only have 40 minutes to discuss. So please make sure that we need to know that we have very tight schedule. So our first topic is the smart construction, the significance and the potential of the smart construction. So maybe the panelists may discuss why the smart construction is attracting the attentions recently, and also how our countries can prepare for the smart construction. So, can anyone talk about the first topic? So maybe then, let me ask the questions to specifically the panelists. So, Dr. Cho, so you are the director of the smart construction project in South Korea. So maybe you are one of the leaders in smart construction technology in South Korea. So can you talk about the recent trends in South Korea for the smart construction?
As I mentioned in my keynote speech in this morning, this is the era of digital transformation. As you know, the construction industry has been very far from digitalization. However, now digitalization influences the fate of a company and an industry. So digitalization should be a very important tool of survival of an industry. Through the speech of today, I found that the level of digital technologies in the area of construction has been very equalized in Asian region. I learned today. So digitalization or digital transformation should be carried out or performed to our survival of our construction industry, I think.
Okay, I think very good opinion. So, so let's move on to the other countries rather than Korea. So, can Professor Supawut in Thailand, can you talk about the trends in Thailand?
Okay, all right, thank you, and hello everybody. So for smart construction in Thailand, I think it starts from the client will start to
transformation that should be carried out or performed to our survival of our construction industry, I think.
All right. Okay.
I think very intelligent. So let's move on to the other countries rather than Korea. So can Professor Supawut in Thailand?
So shall I start now? Okay.
Okay, right. Please go ahead. I think there's some technical problem here. So yep. I'm very sorry about that, and please go ahead.
Okay, for smart construction in Thailand, I think it starts from the client. The client is start to demanding it, especially for the private sector. For example, if you are a designing company, you're working for a large construction project for the private sector in Thailand, if you don't use BIM, you are out. I mean, after people start using smart technology, after people start using BIM, and if you don't have those kind of technology, you are kind of behind. So for the private sector, we have to admit that it moved toward the smart construction a little bit faster than the government sector, because the government sector has a lot of regulation that kind of impede the implementation of BIM or kind of impede the implementation of a smart construction. So to be able to, realize to be able to implement smart construction in government sector, maybe the government have to start to look at some of the regulation, some of the problem that we still impede the implementation of this type of technology. So, but these days, a lot of researchers in Thailand start to realize its benefit, the benefit of smart construction. A lot of players start to, doing a lot of research, kind of artificial intelligence or augmented reality to use in smart construction. But it's still kind of in the early stage, so we still have a lot of way to go. All right, so that's kind of the situation in Thailand.
Okay, it sounds like Thailand is also trying to use the smart construction technologies in the real-world applications, and maybe Korea and Thailand in the future can collaborate together. So, Professor Seo, can you talk about some the trends in other countries rather than the Asia? So, for example, Australia or some other countries.
Thank you, Chairman. Well, actually, when I asked as a panel for this RE AAA, I read the title of the panel discussion, which is Smart Construction Technology and New Business Opportunities. So I kind of prepared the new business opportunities by using SCT. Also, some hurdles that we are facing right now when we use SCT. Why these good technologies are not being used widely? What are the hurdles that we need to break, go over? Those kind of issues. I kind of arranged it. So instead of talking about the smart construction technology going on, other than Asian countries, I'll talk about that. Okay. Well, I am currently leading 3 research groups within the Smart Construction Technology, it's the Center for Smart Construction Technology of Korea, which is directed by Dr. Cho, right here. And those research group, 3 research group, is for earthwork automation, which involves the equipment automation a lot. So I'd like to talk about some hurdles that SCT for also automation is facing, and also some opportunities of the earthwork-related business based on SCT. Okay, let me start with the hurdles. What kind of hurdles do we have? I think Dr. Cho and Professor Shim and President Kim, they all know that we went through a lot of research, and the benefit of SCT, everybody knows. But when it comes to the reality, using it in industry, there are some hurdles. I specialize in earthwork, so I'll talk about the cases of the earthwork. The first hurdle, it's more about general contractors and subcontractors issues. Most of the large contractors, general contractors, they don't directly manage some work sections like earthwork. Instead, they subcontract out. So there are some small companies which only do earthwork. So see, the general contractors invest a lot for SCT in earthwork. However, if they subcontract it out to subcontractors, who gets the benefit of the cost saving and productivity increase? The subcontractors. So large contractors know the effect, a very good effect of the SCT, but kind of not very willing to use it because they are not getting most of the benefit out of it. So that's one hurdle. For earthwork, automatic machine guidance is the key smart construction technology. So, and everybody knows these days, automatic machine guidance is very much needed, but still they are not very widely used, maybe in Korea. Why? That's the reason. And then how come the subcontractors don't use it for their own benefit? They are small companies. It's difficult to invest. Big initial investment is difficult to make for them. So that kind of dilemma as hurdles that we have right now. Professor Shim, maybe I am taking too long.
No, that's fine. It's a very interesting and great opinion.
Yeah.
And it sounds like all our countries are interested in applying the smart construction technologies. So it's an unavoidable trend.
Yeah.
So we need to not just follow, we have to lead this trend.
So, so far I talked about the hurdles, but I need to talk about the opportunities. There are more opportunities than hurdles. I am really, last 10 years, really try hard to foster this automated machine guidance technology within the industry. But there were this kind of hurdles. We still have it, but there are some good opportunities. First, big opportunities that general contractors have. There's a shift for general contractors. They want to do the direct management instead of subcontracting. Let's say for earthwork. They never, a company like Hyundai or POSCO, they didn't directly manage the earthwork. They subcontracted out. But these days, they realize that the productivity increase is extremely low. They want to increase the productivity, meaning the cost savings. But they, when they use the subcontractors, there's a subcontractor controls the productivity. So it is difficult. So they want to do the direct management for small work sessions like earthwork. However, it's going to be difficult for them. They have to hire different workforces like surveying crews, and they have to go through trial and errors for direct management of operational level field management, which they never did for a long time. With smart construction technology, they can reduce the trial and errors. They don't really have to change the workforce portfolio. Instead, they can educate their current engineers to use smart construction technology. So for that kind of shift of the large general contractors, it's a good opportunity. I think that's the point. And another opportunity for design engineering companies, also the subcontractors. I heard that Korea Highway Corporation is preparing for a new project delivery method called design-led turnkey or turnkey led by design engineers. So design companies or engineering companies that are interested in construction work, they can move on to construction, or they can lead the joint venture of the construction as a designer. Why it's possible? Again, for earthwork, building information modeling, drone surveying, those kind of things are the key technologies that are required. Then who has the expertise on that? Beam modeling, beam design, designers. Drone surveying, that's typically designer's job. So they have the capability of using SCT. And if they can form a joint venture with, let's say, earthwork subcontractors, that's a win-win situation. The earthwork subcontractors, they don't need to invest a lot. They can work with the smart construction, design-based engineering companies without general contractors. So that's an opportunity for design engineers and subcontractors, which is possible just because of the smart construction technology. Okay, that's the others and opportunities that I think that SCT, also the contractors, subcontractors that have these days. Okay, thank you.
Okay, so you believe that the smart construction eventually, ultimately can improve and increase the productivity in our the industry, right?
Yeah. Those are already verified through many tests, but why not use the in the industry? My talk was about that. Maybe it was a structure of the construction, design engineering companies, project delivery method, but with the smart construction technology, you can change the project delivery method. Also, change the color of the contractors, those kind of deals. That's a huge benefit for the industry as a whole industry. So that's my point. Yeah.
Okay. So now I'd like to give some opportunities to our international panels over the sea. So maybe we can move on to the next topic. So the second topic was the current development and highlights. So maybe our panelists can discuss the smart construction applications and examples in our countries. So can anyone over the sea talk about the topic, the second topic? Maybe let me ask Mr. Na from Singapore. Can you talk about some applications in Singapore? Mr. Na, I'm very sorry, but we can't hear anything. So maybe your microphone is muted.
Yes. Can you all hear me now?
Yes. Very good.
Good afternoon. Okay, I'd like to just share our perspective from Singapore. So I think I agree with the panelists earlier on that I think as a contractor in Singapore, I think one of our biggest hurdle is really the cost of implementing. So there are a lot of this smart technology out there. And of course, in my presentation earlier on, I also talked about some of the BIM technology that we are using, some of the DFMA that is already available and we are already using. Of course, we have got no doubt that this allow us to have a better visualization when we are actually doing work on site. But I think some of the hurdles that we are talking about is still the cost. So in Singapore, I like to call that the push and the pull factor. So I think the push factor comes from a lot of the government agency that we are working with. So you can see that the newer and the bigger contract, they are already putting in the BIM requirement and specified certain requirement that they want to have when we tender for the project. So of course, on the cost part, then it comes on the pull factor. Singapore's this Building Construction Authority is also helping local contractors that when we actually embark on all these form of technology, whether the smart technology or the BIM that we're using, the DFMA method, there are some sort of funding that is available to us so that we can actually tap on them so that to help us to defray some of this cost. So in terms of the technology that we are using, I mean, for civil engineering contractors, when we are doing a lot of routes, we uses a lot of this Civil 3D, and then also mention about the TECLA that we actually plot onto the drawings and stuff like that. So these are already very matured software that you can easily find in Singapore. Really, it's about getting everybody on board. Like I think the panelists mentioned, it's not only the main contractor, the subcontractors, our prefabricators. That is why when we choose the stakeholder that we are working with, choose the subcontractor that we are working with, we have to make sure that they are in line with us, to make sure that because when we draw a BIM drawing and in order to pass this model to the prefabricator, the prefabricator must have the same software in order to build on this construction drawing for us, or the shop drawing. So if they do not have such software, then it is quite difficult that everything has to be relied on the main contractor to do the work. So the ecosystem is actually very important. And I think one of the panelists did mention, it is already happening 5-7 years ago. But the COVID is really just a catalyst that actually pushed everything. Today, a lot of us are working from different parts of the world. We no longer can see each other so freely now. So with this technology, it actually helps us. And we really see the tangible benefit and the intangible benefit. Yeah, that's the view from Singapore side, yeah.
Okay, thank you very much. I also completely agree with you that the fact that ecosystem is important has been proved in other areas as well. So I agree. So I'd like to I'd like to hear the opinions from Mr. Satria, Indonesia.
Hello, good
Okay,
afternoon.
please go ahead.
Yeah. Yeah, maybe I can share that regarding the digital information developed is already quite mature. I think in Indonesia already more than 10 years. But the main issue is how to bring this information to the user, to the decision maker. So it's need a kind of platform how to communicate this, so this information can be accessed maybe with less expensive software or maybe even a free application. So that is the idea. So the information will be useful among the stakeholders. That's what I think regarding in developing or growing the ecosystem. And then also how to bring this to another decision maker like such as finance. How to bring the BIM information to the decision maker regarding the budgeting, the cost controlling. So we need to bring the information such as volume into the SAP, for example, for ERP system. So those guys who plan and control the budgeting also can benefit this process. And then I think this technology is already quite robust, yeah. But also we need to make a collaboration with the other stakeholders like a consultant and subcontractors, and how the contract scheme can accelerate the implementation of this digital information. Otherwise, it's already quite so long. Indonesia, we are adopting BIM, I think already more than 10 years ago, but the benefit only within the internally, within the contractor or consultant internally. But actually, it can be a multiplier. The benefit is can be collaborate with other stakeholders. How it can make a decision maker can be faster and more accountable if those processes are conducted within the electronic data distribution. So I think that's what we concern to develop more than just how to generate those informations.
Okay, thank you very much for your opinion. I agree that the collaboration is very important, and the same situation is happening in Korea too. So next, I'd like to hear the opinion from Mr. Kim.
Yes. Sorry. Because you already have many presentations today, so frankly speaking, I think I don't need to explain Korean case more, but because fortunately I could have many experience in other countries, including Singapore and Japan, sometimes Middle East countries. So I would like to explain the difference between Korea and other countries. in my viewpoint, there is no difference between Korean and other countries because we use same solution from global company, and we have many network with other countries specialists and engineers. So we were being provided for smart construction technology, but nowadays there are smart construction boom in Korea. So most construction company have a construction team, smart construction team inside, and most of all, Korean government support many R&D projects. So we are developing many unique solutions, especially in the case of Korean special status, we cannot use the commercial platform based on cloud solutions. So we need to develop the government cloud-based platforms. So maybe some years later, we can get the unique solution from Korea because many people are developing many solutions. So I would like to deliver this unique solution to other countries for many projects. Okay, thank you.
Okay, so Mr. Kim talked about the Korean environment in the smart construction. Actually, I'd like to move on to the next topic, the third one, which is how we can foster the smart construction in the field of the construction area. But we already covered many things in this regard. For example, the governmental role, and also how we can collaborate with each other. But I'd like to ask our the panelists to discuss more about the smart construction. May I ask Ms. Wardani? So you haven't talked anything so far, so I'd like to give you the opportunity for you to share your opinions and your thoughts.
Thank you. First of all, I would like to express my gratitude to the major cause coordination, co-organizer, sponsor, and then for the 9th Business Forum, because for making this forum successfully done. I would like to thank also my colleagues, various speakers from the session we had, and my colleagues in the panel discussion today. And I have observed the excellent speaker presentation and attractive discussion in this panel session. So I can conclude that the purpose of this forum actually has been completely accomplished. Referring the REAAA objective, I mean the REAAA Business Forum, we have 6 points: facilitating intra-regional transfer of technology, 2, cooperation with national and international organizations to support and supplement business opportunity. The third, providing a catalyst for future development and activities. Number 4, establishing better interfunctional links between road planners, designers, construction engineers, technologies, manufacturers, and various other services and traders associated with the road engineering. There are also interested parties from developer or industrial estate, developer residential and commercial estate, and tourism. Number 5, being a regional focal point permitting to the cross-facilitation of ideas among engineers to achieve creating better understanding among member countries. Number 6, being a regional information and service center. Thus, REAAA Business Forum actually as well placed is a platform to explore and engage opportunities, new business and internal cooperation to support mutual development, which can include technology transfer and project development in the area of, but not limited to, smart construction technology and road engineering as a topic today. In ERAAA Business Forum, actually, we can representative can share the updates of new developments, business technology from the region and member countries. It is an event where introductions are made and facilitate contacts and ideas are exchanged. So cooperation and partnership can be implemented in a project. As example, because I'm from Republic Indonesia, one of the most progressive developing countries in the region, where infrastructure such as township roads, toll roads, elevated toll roads, and continuously develop many parts of this country, using by the ERAAA Business Forum. We can also doing some role if you are looking for business opportunities, local partners that are goal-gathered and target-oriented, guaranteed to get results. I'm very confident that we can help in facilitating and connecting you with the right partner in Indonesia, and also can be other countries doing the same way, then connecting through the ERAAA Business Forum. So I'm really wishing the future prosperity for all of us in Asia, Australasia. This is all from me. Thank you.
Thank you very much for your great opinion. So before we close this session, I'd like to give one last the opportunity to our panelists. If you have any other thoughts and opinions to share, then you can speak out now. Please go ahead.
Thank you, Chairman. I'd like to say very shortly. And finally, I'd like to emphasize 3 points. The first one is the importance of government or public sector's support or effort to prepare legal system and to improve project process to promote smart construction. The second is the education and the training of digital technology for our engineers and the students. The final one is the standardization of digital data to be operated based on platform or cloud. Thank you.
Okay, thank you for your opinion. And so I'd like to turn to our audience to give them the opportunity to make questions. Any question from the audience? Yeah, please go ahead.
For many cases in each countries to development smart construction technology and the law of the public sector is very important things. So I have some questions about each countries, Thailand, Singapore, and Indonesia, the government, especially public sector's efforts, sometimes a policy, especially master plan, yeah. And 그리고 한국에 계시는 민간 부분에서 참여하셨던.
And also, I'd like to question to the CEO Kim, who are working in a private sector. So in a public sector, you want to request to the public and government agencies what would be needed for the facilitating the smart construction technology.
Anyone who can answer the question to the audience? Maybe Mr. Kim, can you speak first?
Yes. It's already mentioned. Here are many government support and roadmap, especially we already made a smart construction roadmap, and nowadays we should follow the BIM roadmap of government. So we tried to make some software to meet the requirement of full BIM. Yes, we call full BIM or integrated BIM after two-track BIM. So, but we need to have many collaboration with the software to make this solution. So I would like to ask the government to support software company to deliver the good solution for our integrated BIM roadmap. Yes, plus. Okay, thank you.
Okay, so the first question will be directed to our international panels. So can anybody answer his question? Okay, please go ahead.
All right, I can go first. All right. For the government project in Thailand, we have to admit that the government project is still kind of behind the private sector in terms of smart construction. For the government project, to be able to implement the smart technology, we have to make the high executive in the government sector to buy in, to realize the benefit of smart construction. We have to prove to those high executives that smart construction can help to achieve higher construction quality, can help to achieve higher productivity and saving costs and a safer environment in the construction site. So once the head of department realizes the benefit of smart construction, many people in the organization will follow, but we're still not at that stage yet in Thailand. Okay, so if the government sector can set some standard, if the government sector can set some implementation guideline and regulation for the new technology, a lot of people will follow that. Okay, but one of the problems in implementing a smart technology in the government sector is the government have to prepare the personnel for the new technology. For example, many government officers are kind of old, and they have been working or using AutoCAD in the past 10 or 20 years. And today, we go to them and telling them that we have to change from AutoCAD to BIM, as that's not easy for them to change. And we cannot leave these people behind. So that's kind of one of the biggest obstacles that we have right now to change the culture in the organization, to change the way we work, to change the people to work on the new technology. That's kind of the problem that we have in Thailand right now. Thank you.
Okay, anyone else to answer his question?
Maybe can I just add it from the Singapore perspective? I think the question was the role of the government project. So I did mention earlier on, I think in Singapore it started for a while already, that a lot of our government procured projects, what they do is that they no longer look only at the price, but they also look at the quality. So in which the productivity of how we actually continue the project and complete the project also plays a part. So today, if we have got a project, we are looking at the price taking about 60 to 70%, and 10% will come from the productivity, which is the smart construction that we are talking about, how we can do it in a safer manner, in a more productive manner. And then the rest of the 20% is the safety aspect of the projects. So the contractors that is tendering for the government project, they already specify, I think in the newer project, they already specify things like the 3D beam, 4D, and some is even 5D for the public projects like the MRT projects or the roads project, the mega projects. that is already specified. So this is what we call the push factor in Singapore. So they are pushing us to make sure that we have got this capability before we are able to take on a project of such scale. Then I think the other factor that I talked about earlier on is the pull factor, which when we embark on such technology, of course, we need to look at the return of our investment. That is where the building construction in the authority in Singapore, they will actually work with us, and certain program that we actually work out the initiative that we do. And as long as we submit to them, they look at it, there are some cost saving or in terms of productivity saving that we can improve the workflow, and they will actually collaborate with us and to subsidize part of the cost. So this is generally happening in Singapore, the push and the pull factor that the government is actually doing. Thank you.
Okay, thank you very much. Do we have anyone else to talk about that?
Okay, I can add a little bit more.
Okay, please go ahead.
Okay, yeah, I'm observing Singapore policy regarding BIM. It's quite inspiring me. Even I also learned from how the Singapore government, and then quite successful. And then from my observation, I think what's interesting is the constraint is also accelerating the implementation of this technology. What I heard is in Singapore, they have a limitation of work man hour, the number of man hour, working time is also limited. So it's accelerate the implementation of technology. But in our country, it's very different. Yeah. We have a lot of workforce. Yeah. Even in my company, we have 4,000 employees and more. So we are quite careful in establishing regulation. But however, it's already started by a private sector within their own initiative to adopt or implement a new technology or smart technology, even since 2010 or less. Yeah. But our government also pay attention and then observe, and so gradually establish also our policy and roadmap regarding this smart construction technology. For example, like in 2018, they already established that certain area of the project size must be implement BIM for structure architect MEP. And then in 2021, they also established for the implementation BIM for the road and bridge construction. So I think this is quite an improvement. Also, an assessment of the readiness for Industry 4.0. This is also accelerate the adoption or the implementation of the high technology for the construction. But again, they also have to be careful in terms of implementing policy regarding using high technology, because we have a lot of workforce in the company, so we have to align with the growth of the skill, competence of the human resources in Indonesia. But government already established a policy to drive the acceleration of the implementation of smart technology. And hopefully in the new city, our capital city in Kalimantan, this will be the playground for implementing the smart construction in the location, hopefully. Yeah, I think that's all from me. Thank you very much.
Okay, so I don't want to give some pressure to Ms. Wardani, but if you have any, if you wish to answer the question, then maybe you can go ahead. Otherwise, you can also skip. Okay, all right. So any other question from the audience? Okay, so it's almost time to finish. So I think the panel discussion today was very fruitful, and we shared our knowledge and experience all together. And I hope in the future, and also this kind of today's the activity is also one of our the efforts to foster the smart construction. So Okay, thank you very much for coming, and this concludes the panel discussion session. Thank you very much.
Thank you, Professor Shim and all the panels. It was really profound and constructive discussion. So please give them a big round of applause. And Professor Shim and panels, you may return to your seat. And for your information, please visit Korea Road Association's website for program book. Distinguished guests and ladies and gentlemen, we have come to the end of today's forum. So let me conclude by thanking all of you for your precious time and contribution with valuable insights. Indeed, I have been impressed that you are shaping important dialogues that enable the smart construction technology to move forward. It was my honor to be a part of the 9th REAAA Business Forum today, and I hope to see you at the next REAAA Business Forum with more innovative ideas and thoughts. Thank you very much.